We survived.
Did we?
I don't know.
Barely. I got to tell you, I'm impressed. I'm standing here right now.
Me too. No, there was a crowd last night. We were probably like 60 persons actually closed the place, which was nice.
Yeah. I hope you guys had a good time. Very good.
Do we have Assad?
Yay!
Nice. So before we start, was anyone here doing karaoke?
Yay!
If you weren't,
oh no.
You want to see the final boss?
Oh no.
Nej.
That was impressive and embarrassing in equal measures.
Yeah. That's like the wrap-up song, because when I logged into this karaoke thing, it was like, do you want to play your last song? And it was Stadius.
Yeah.
So it's pretty fun. But okay, adulting. In case of fires and zombies?
Rules are the same. There are emergency exits at the back. Follow the green signs.
Yep. Restrooms on either side. You probably know where they are already. If you don't pee on the floor. Badges, you need them. You sort of made it here, so
yeah,
you have it,
should be
hopefully.
Right.
And if you don't, good on you that you managed to get so far. Please visit our sponsors. And this is basically the gist for today, 12:30 to 2, lunch.
Same as yesterday, same rules apply.
Exactly.
We'll have some of these in your goodie bags, hopefully.
Yeah, if you lost them,
if you have any dietary restrictions, you should go to the veranda.
Cool.
So
and
hopefully you have that.
One more thing. The Hacker Award things, we got a few submissions to the Swedish Hacker Awards. But please send in more. And if you are lazy and don't want to send in anything, just find Love or Benjamin. You two need to do it. They're back there. Find them and do a verbal submission. It will be fun. Don't be shy.
Come on, guys. We have some good prizes for it as well.
Yeah, we do. We actually do. What else?
We actually do this here. Come on, guys.
We got these Disney pins. Anyone who won the CTF? They got really sad when they understood what it was. I'm not sure that I do, though.
I was covered in beer for some reason.
Let's.
All right. What
else? Say something.
All right. Something.
That was it. What else? Have I forgotten anything?
No, I think you're fine. Should we not just move on to introducing the first speaker of the day?
I think it's time, right?
I think so, too.
So please help us welcome Christian. Technical things. Go. Yeah, I have no idea. I'm just here. Moral support. I have a lever.
Yes.
Hey. And I'm going to press this one. So you have. Go ahead.
Perfect. Yeah, so good morning, everyone. I hope I kind of pronounced that somewhat correctly. Just a quick question, who is still overhung from last night? Raise your hand. Okay, at least a few. I don't really believe that that's all of them. But I will try to do my best to not make you fall asleep. So I will be talking about mesh hacks, or basically like how I discovered that like consumer home routers are still a pretty easy target to hack. So just a quick introduction to me. I'm Christian. I work at SYS in Germany. I've been a pen tester since 2023, and I mostly do like embedded stuff. And yeah, you can see my contact there. Yesterday I heard that Mastodon is like what the cool kids use now, so I added this too. And yeah, so I will jump right in. how did this like start? It was basically like quite early in my embedded hacking career. So I was switching to the embedded team back at work, and they were like, well, we don't really have a project right now, but we do have this old router just lying around. Maybe you want to have a look at it to like improve your skills and stuff. So I did, and I poked around it and saw that this router can like build a mesh, like you can connect multiple routers together, and this pretty much worked like magic. You could just connect them together without having to configure pretty much anything. And I also asked myself, well, did anyone analyze this before? Because this looks quite interesting. And well, the answer was no, nobody looked at it. So this is the model I got, which is a pretty old Linksys here. We also got another one, like a newer model to like verify stuff on it, so we don't use the super old dated hardware there. So the first step of analyzing this was actually to like get a reverse shell on it. So when you analyze like hardware, you want to more likely analyze this pretty much dynamically, like we want to see what the device actually does in action. So I poked around the firmware of it to maybe find an exploit I could use to get basically a shell on the device. And I found this little script. This is just part of it, and in there the auto mounting of USB drives happens. And maybe some of you already noticed something weird about this, but it's grabbing the with the USB label tool up there. It is grabbing like the label of the partition and using this inside the path completely like unsanitized. So I thought to myself, well, what happens if I put this in the partition name, or even this? And yes, we can pretty much mount the USB drive anywhere we want. So we just use a pretty simple path traversal as the partition label here, and suddenly the USB drive gets mounted wherever we want. And if we mount it in like /cron every minute, every script stored on the USB drive will be run every minute. So what we do with it, we obviously get a reverse shell from the device. So simple listener just being there to grab the connection. And with every good like embedded device, everything is running as root. So there's no need for like privilege escalation and stuff. So with like full access to the device at this point, basically, we started to really analyze the mesh feature. So basically, you pair them over Bluetooth Low Energy. So these routers, you have two of them, you want to pair them to like build up a mesh. You simply just do this over Bluetooth. This happens totally transparent to the user. So the unconfigured router, if you like have one and just put it outside of the box, it will actually send out Bluetooth advertisements. So there you can see like some of it. And the mesh master, which will be the configured router at this point, so you have one that's already set up, will actually connect to those. And at this point, I just basically cloned the advertisement, broadcasted it, and waited for the router to connect to me, so I can see what like it does. And it actually sends data to us. So there you can see just a part of it, of the data we got from the router. To trigger this, all we had to do was press the reset button 5 times on the device. This is like the default way of doing the pairing process. So you need physical access for this. And as you can see, there are 2 groups of stuff here. The first one kind of looks like some Wi-Fi credentials, because there's like SSID, passphrase, and the second one also look kind of like login data. But well, what are these for? And this is the time where I will introduce you to like the root of all evil here. This is pretty much 2 binaries on the device, which caused all of the problems on it. And this is the SCT server and the SCT client. I have no idea what SCT actually stands for. It might stand for Smart Connect Tool or simply Smart Connect. This is how this is called internally sometimes. So the mesh itself is called Intelligent Mesh, but this is just a marketing name, and inside it, it's mostly called Smart Connect. So as you can see, the SCT server is actually running on the router. So on port 6060, on pretty much all interfaces, it just listens there for incoming connections. And the SCT client is also present on the router, and it even gives us a little help. So if you just put in the command --help, and we can see that there are some command line argument that it wants, and most notably, it wants a username and a password. So, well, what do? We simply give the tool what it wants, and in there, we just put in the username, the password we got over Bluetooth, and we also put in just an ID, the test ID. This is just pretty irrelevant here. And also, we put in an IP and a port. In this case, I'm using an IP and a port from like my laptop at the time, so I was able to intercept the connection and look at it and simply redirected it back to the router because, well, I only had one device at this point. And so I looked at the traffic, and I saw this. This is TLS SRP, which I had never heard of before. It is TLS, which is secured with a username and a password. So the username and password actually does the crypto in this case. So there's no certificates, nothing. It's just the username and password. And if you have a closer look at the bottom right there, you can see a username, which is transmitted in clear text. And this username just corresponds with the username we put up there. So we are now pretty sure that the username and password we gave to the tool are actually the username and password for the TLS SRP connection. So because TLS SRP is pretty unknown, I would say, and nobody has touched it whatsoever. There's like no tool for it to like machine in the middle, because all the tools just use the certificates, for example. So I had to write my own. This is just a really ugly program, which I wrote in C, and I don't know C at all. But I had to somehow get this interception working. So this tool basically terminates the TLS connection and builds a new connection to the target, and simply is able to decrypt the traffic in between because, well, in this case, the username and password is known. So it just simply displays what is sent basically over the network. And if we have a closer look here, you might see a pretty weird entry in there, which is this one. It's like admin password. And I know this password because I put this password in like the web GUI from the router. Like when you configure the router, you basically have to like put in the admin password and like configure an admin password for like the configuration and stuff. And here the SCT server just gives this to us if we asked it. So some of you might think, well, at least we need to be some in like the network because, well, we need to talk to this 6060 port. But no, we got the Wi-Fi credentials before over Bluetooth, and this is actually real Wi-Fi credentials. So there is a hidden network where we can connect to, and we can reach the port 6060. And we actually have our first advisory here because, well, I only need physical access, and if I have physical access, I can just write a simple tool which connects over Bluetooth. I have to press the button 5 times, and we get pretty much all the data of the router that we want. And there you can also see the admin password again. You can also see like Wi-Fi credentials. These are the proper Wi-Fi credentials of the router. But this is pretty normal, I would say, in like router configuration stuff, at least for like home devices, because, well, the second one would have to know the password to like rebroadcast it again. So you can like extend the mesh. But yeah, this is the first advisory I got. But as we all know, physical access is pretty lame. And we want to have an exploit that works without physical access because these are way cooler. So the same attack doesn't work over just LAN because, well, we don't have the TLS SRP connections. We only get them over Bluetooth. So there is like no way to access this at this point. But the SCT server is actually reachable over LAN. So you saw before, it is listening on every interface, so we can actually reach it. So I took a look at the binary, just threw it into Ghidra and have a look around, and I found out that it actually does not really do the validation of the username and password itself. It hands that off to a little script there, smcdb_auth, and this will do the password verification stuff. So we look at the script in there. This is just, again, part of it. And there you can see that this is pretty much divided into 2 parts. the first 6 lines check the username for invalid characters, and just returns, there you can see invalid characters. And the last 3 lines retrieve this password from a database using SQL. There's like an SQLite database stored on the device where like the TLS SAP connections and credentials are stored. And if we have a closer look, maybe some of you already noticed the problem in line 2, because it is using grep to check if the username matches the regex, but grep works line-based. So the actual description would be that the first 6 lines check if any line of the username contain valid characters. And if that's the case, I can simply do an SQL injection at that point by simply putting in a new line character, having the first character just an A, so that's valid to the script, and the second one is just SQL. And I did a little insert statement here to just put in credentials into the database, and in the next step, well, we can exploit the same vulnerability again, because we can just create our own credentials in the database, then the credentials are known, and then we can connect again. And maybe some of you already noticed another problem with this, which is this part right here. Like if you look at it, how it calls the script, it basically uses printf to construct this string, this command. The param1 is the username here, by the way, and then calls popen on it. So there's not only a SQL injection in there, but there's also a command injection in the username. So we can simply insert a semicolon and have root access directly on the device without even like inserting our own credentials at that point. And yeah, well, it runs as root like everything else. But there's a problem with this. This is already fixed in newer versions. This was a problem in the old one we got. Newer models already have fixed that, have addressed it. They're now doing it correctly. So what is the solution for this? Obviously, we need another code execution. So I looked again at the communication there and noticed that when the communication is started with like this weird TCP 6060 protocol, there's a sync request. So the client does a sync request to the device. And while I thought, is there anything else than a sync request? And there's also update, and we can put in stuff and some data, and this actually updates stuff on the device. So there's this sysconfig tool, which is basically a key value store on the device, and the update request basically updates that. And there's another script, which lives in the cron every minute folder again, where this one takes some of these key value variables and sets them as environment variables for the script. But the way it does it is using eval. So eval never ends well, and this is the case here too. So basically, we can put in the exact same payload as before and have command execution on the device. For this, we need the SQL injection because, well, we would need to have proper TLS SAP credentials at this time. But, well, there's the next code execution. This could have been the end, but it isn't. So everything was finished at this point. Like this was a week maybe of poking around, and I did manage to get like the advisories ready to report them to Linksys and everything, and to do the proof of concepts. I simply went back on the router to get some data and everything, and I ran one more command I hadn't ran before, which is this one, IP tables. I just listed the firewall rules, and I noticed these 4. And I kind of looked like this at them, because especially this line kind of freaked me out. If you look at them a bit more precise, you will see that it basically allows incoming traffic on the WAN interface, which is ETH0 in this case, if the traffic originates from TCP port 5222, no matter what. It just accepts it. But at this time, I thought, well, I might have overlooked something because, well, this would be pretty dangerous. And so I thought, well, there might be some other things blocking it or stuff like this. So, but this was pretty easy to check. So I simply fired up Nmap, ran a port scan, in this case port 443, which is the web interface of the device, plugged into the WAN interface, and simply used an arbitrary source port, which is 51222 in this case. And as expected, the packet gets dropped. So now we just put in the 5222 and see what happens. And yeah, it's actually open now. So to make this a bit more clear, this allows us to use all of the previously shown exploits that work over like the TCP 6060 protocol over the internet now, basically unauthenticated, because we can well just insert our own credentials with SQL in there. And at the time of discovering this, I did a quick scan around the internet, and turned out about 12,000 devices had exactly this problem, which were connected to the internet right now. So this would make quite a good botnet. And then I started reporting this to Linksys, and the response I got first was this: hello, this appears to be an issue with either negligible security impact or better categorized as support request. Little disclaimer, this didn't come from Linksys at the time. This came from Bugcrowd, which is the platform Linksys uses for their vulnerability management. But it summarizes quite well how the communication with Linksys went, which I will be talking about now. So a bit about the problems of responsible disclosure, because we got a pretty serious vulnerability here, and obviously we want to report it to the manufacturer. Quick disclaimer again, this is not only applicable to Linksys. Quite a lot of manufacturers actually behave like this when we report stuff to them. But, well, in this case, it was Linksys, so I'm talking about them. So this is in 2025. On March 7th, I simply first contacted them. There's a submission form on the website of Linksys, and this is basically an iframe, which is like the submission form from Bugcrowd. So you fill out all the information, click send, and it actually gets sent via Bugcrowd. So they use this for their vulnerability management. And March 18th, a few days later, still no response. So I decided to claim the vulnerabilities. When I submitted them, I got like an email where it says, hey, you have the option to claim the vulnerabilities. You have to set up an account on Bugcrowd and everything. Didn't feel doing like this at the time, because I thought, well, I left my email, so they will contact me via email, but apparently they didn't. And then I noticed when I logged in, I didn't get a notification via email. I had to create an account, claim the vulnerabilities, log in, and then I saw the message I read before, like the negligible security impact. And they basically told me, hey, you submitted this wrong. You need to do a submission for each vulnerability. So I just filled the form out once and put everything in there, but apparently they didn't like that, so I filled this out 6 more times and sent it to them. 2 days later, I got a message from them, still Bugcrowd, still no response from Linksys. Your steps are unclear. This is like the Bluetooth one I showed at the beginning. Maybe this was not well explained by me. So on March 27th, 7 days later, I was on vacation, so I didn't saw the message. I submitted more information. And the response from Bugcrowd was basically, oops, too late. You have to fill out the submission form again. So I again filled out the submission form and sent them again all the information. And on April 7th, this is now 1 month into this whole process, still no response from Linksys. So I decided to email a couple of email addresses at this point. At the time, sometime before, Linksys was owned by Belkin, and the code on the device had still all the copyright Belkin in there. So I decided, well, maybe actually Belkin is a proper communication partner in this case. I didn't send any details to them, just said them, hey, I submitted this to Bugcrowd. Maybe you have to look on the platform to like see it. So I messaged support@belkin.com, and this returned, please note this email is no longer checked. So I messaged info@belkin.com, which returned invalid recipient. So I gave up with Belkin and decided, well, I try the Linksys addresses. So I contacted info@linksys.com, which returned recipient address rejected. And then I also found 3 more addresses that actually worked. So comms@linksys.com, privacy@linksys.com. And my favorite by far, linksyscares@linksys.com. And later that day, I actually got a response from them. on Bugcrowd, not over email, I get no response over email, but over Bugcrowd, they responded, well, our team is in the process of reproducing the issues, so maybe someone saw the emails actually. And, well, we will let you know once we know the next steps. I said, oh, great, now I'm like getting this to work finally. And like a week later, I asked, so how's it going? I have heard nothing so far, like what you're doing. And you notice this little star down there. This is like a premium feature of Bugcrowd. You can actually request a response, which is like, you can just chat with them. There's like a chat window where you can send messages, but you can also request a response, which will put like a blocker on them. I have no idea how this works, but this is a feature you could apparently do. So I tried this to like actually get a response from them. But, well, in this case, I didn't. So on May 5th, I decided to contact the BSI, which is the Federal Security Agency of Germany, which is the Bundesamt für Sicherheit in der Informationstechnik. And because, well, this is kind of critical, and these Linksys devices are actually sold in, like, Germany, and, well, they are maybe a bit vulnerable. So, yeah, I contacted the BSI, and like a miracle, a day later, Linksys responded. The BSI didn't contact them at all at this point. It was just, maybe they felt it in their bones that they contacted the authority. I have no idea. But they, well, responded, apologies. We verified your submission, testing new firmware, thanks you so much, blah, 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 a bit of PR stuff. And they also asked me, would you like early access to the firmware? And I was like, yeah, of course, great. I can test, like, what did they change to make the fixes and stuff. And I also asked, like, by the way, only one vulnerability is marked as triaged on the website so far, so have you looked at the other ones, or just this one? This is, by the way, the most critical, obviously, like the wrong IP tables rules in this case. And then this happened, which is absolutely nothing. So they, again, don't reply. This is now 2 months into this process. Still no fix for 12,000 vulnerable devices on the internet. And I asked again, anyone there? And you noticed I again used the premium feature of Bugcrowd to like get a response. And they immediately responded and said, yeah, well, the internet face vulnerability is the first one we fixed because this is the most critical, which is, yeah, I guess. And they also asked me, would you like early access to the firmware? Which was, yeah, please, I really want that. You already asked it. And I also asked, like, what time window are you planning for releasing the fix? Because, again, this is kind of critical. And, well, yeah, again, absolutely nothing happened. And they didn't respond at all again. And so I asked again, like, hello, Linksys, kind of critical. And you noticed these stars missing there because I used up all my request a response quota, apparently. You can only do that twice on Bugcrowd before they stop allowing you to use this feature. So you can just contact them normally over there, but as we know, they would never respond to it. So on June 4th, 3 months into this, I asked the BSI for help. In the meantime, they actually responded, but it was like, yeah, I'm on track again. They responded in the meantime. I'm kind of working it out here, and basically left them on hold. But now I'm just asking the BSI, please help. I have no idea what I should do. And this was what I imagined would happen. And they actually contacted them. So they wrote an email to them, and this time they actually responded to the email. So a few days later, I got an email from an actual person at Linksys, which was, we will be releasing a fix later this week. And once the rollout is complete, we will have a look at the other vulnerabilities. I was like, oh, so you haven't even looked at the other ones so far? This is now 3.5 months into this. And they also said, yeah, well, except the Bluetooth one, that's a feature, not a bug. We don't fix that at all. And what I found quite funny at this time was the email, the BSI like message also like comments, privacy, like the emails I shown before. And in the response from Linksys, they immediately put Linksys legal in the CC of the mail to like be really sure here. And yeah, well, I then responded obviously, well, thanks for the info, but by the way, did you just remove the firewall and this took you 3.5 months? Or is this like an actual fix of the vulnerabilities? And also, like, what time window are you planning for the rest of the vulnerabilities? Because, well, we want to publish this and kind of talk about it because, well, the disclosure part of responsible disclosure. And yeah, I never got a response again from them. Either I'm blocked by them or marked as spam by now. But no, I didn't get anything back. I messaged them multiple times, even when I was like, well, we will publish this now. No response whatsoever. So the end of the story is that I published 6 vulnerabilities, 5 of them completely unpatched, 3 RCEs. Never got early access to the firmware and never heard of Linksys ever again. So we published it, it went on, no response from them whatsoever. The one vulnerability is actually fixed, the one from the internet. They actually removed the firewall rule, but this is all they did. No, nothing else happened. So a quick look into the future. So what the future might look like, maybe like this. So there are plenty of manufacturers with their weird mesh technologies, so there's no standard for it. So every manufacturer basically does their own thing to do. So there are plenty of weird protocols, weird stuff that's happening. So maybe I will be here next year with like a similar talk about just another manufacturer, because, well, they screwed it up too. And now, thank you very much. If you have questions, feel free to ask. We have the blog post, we have some advisories, and if you want to stay in touch, you can.
Thank you very much. Nice talk. Okay, Swedes, make me proud. Questions? Hands? Oh, come on, man. Seriously? Do it. We have one. Obviously, it's way over there. Well, nicely hacked, sir. I'm coming. No, thank you, Shoshana. Save me. Is it on? There is a button below. Don't press it. I'm just kidding.
It is working, I can hear you. No, I can't hear you.
It's a toggle switch.
Now it is.
Ah,
Thank you very much for the presentation. I will not be able to sleep well tonight because of that horror, so I need to look at my TP-Link router when I get home. Question about that. Is it something that want you look for the rest of the audience here to when it comes to choosing your own router? Or do you feel like, don't go for Linksys ever again?
well, Linksys has a quite a backstory. It was like a few years ago, they actually like found a real backdoor in the firmware. I'm not sure what happened here. Some people said, well, this kind of looked like a backdoor too. So maybe I wouldn't choose Linksys like at my primary source of routers. But I'm sure quite a lot of manufacturers are pretty much the same. Maybe not over the internet, but home routers still are, as I said, a pretty easy target. So there's still a lot of vulnerabilities in them we actually discover. So yeah, but I don't really like take this into account when choosing like a router at home. I'm sure a lot of people just run open WRT on it and some old hardware or something like that and use this one. But yeah, the Linksys stuff, it is kind of sketchy. So don't want to put on a recommendation out here, but maybe you should think about if you should use this.
We're going back to that image of the guy that looks at the distance with the text saying, it's all getting so tiresome. Thank you very much.
We have another one. Nice. And it was close as well. Holy shit. Here you go, noble sir.
Hi, you already mentioned this a bit, but this firewall rule, it doesn't look like an accident to me. So did you ever dig into, was there anything listening on the inside for requests on that port or something like that?
Yeah, so the port in question there, the 5222, is used for some XMPP communication. It is not used now. I think what might have happened here that it was used in the past for like, they have like a cloud connection stuff, so you can put this to your account and then basically configure the router from anywhere you want, just over the internet. And I think in the past they used XMPP for this and basically like accidentally thought they would need to open a port for this, I don't know, and just open this whole thing completely up. But right now there's nothing specifically listening on this port or doing the communication over it. At least I didn't see anything else that goes over there. It's just pretty much dead wool that lives there.
Anyone else? Now you're warming up, making me proud. Thank you. Here you go.
Well, thank you for the presentation. Just a quick question at the end. So are the vulnerabilities patched now?
No. So the internet-facing one, this is patched. They actually did release a fix about it, which actually fixes it. They didn't just release an update to only remove the firewall rule. They also did like feature updates in this. So it is a quite big update and took some time to look through, but to my knowledge, they actually did fix the firewall rule. But the other vulnerabilities are still there. So you can still plug in a USB drive and everything and get root on the device. So this is not fixed at all.
Okay, I actually have a question.
Yeah.
Christian, since you're German,
Yes.
why isn't Fritzbox your target?
Yeah, well, Fritzbox is actually quite good, I would say, regards of security. Lots of people look at it, lots of people analyze it, so haven't really looked into it at all. But back at work, we have a few colleagues who are really passionate about Fritzbox and looking at them. But yeah, so far, no vulnerabilities, at least we found there.
Okay, we have one more question.
Thanks for a great presentation. Considering the poor response that you got, do you think when the Cyber Resilience Act is introduced that there will be an actual change in how vendors respond, or is that just something that will be ignored?
Sorry, again?
When the Cyber Resilience Act comes into play this year and next, do you think that'll be a change for how vendors respond?
Yeah, well, I absolutely hope so, but I'm not so sure about it. It should make things better with the Cyber Resilience Act, definitely. And we really hope that this gets better, because, well, talking to manufacturers about like responsible disclosure is always pretty hard. But I really hope it gets better, but I really don't know if this actually happens. So we will see, we have to look, but hopefully it will actually get a lot better than this.
Nice. So thank you very much for a good talk, Christian.
Thank you.
And yeah, we'll be back in half an hour-ish, 28 minutes. So go visit our sponsors, have a coffee, some energy drinks, whatever you fancy.
Good? All right. Well, it's day 2, talk 2. Hope you're still with me, not too bleary-eyed. And I hope you are ready for this talk on Linux process injection. I know I am. So please join me in welcoming our next speaker, Laura.
Oh. Wait, that was swap.
And then switch. Because it won't recognize the screen otherwise. So let's do, technology. Let's see. So move it to the other screen.
How?
So that just
And we are good. Okay, yay! Woo! All right, everybody. First of all, the name is Laura. Today we're going to be talking about the process. No, we're going to be talking about process injection, specifically into distro of Linux. Many offensive write-ups, books, and techniques say that basically Linux process injection is a done deal. You learn LD preloader, ptrace, which are the most traditional techniques for process injection, and those are the only injection methods. You learn them in a textbook manner, but when you deploy them in actual production environments, they always fail. Many of us are still in that old mental state that Linux doesn't have any sort of protection. They don't have any EDRs or these telemetry stacks protecting them, but in reality, they do. You can just deploy an injection with ptrace and something just running CrowdStrike Falcon, it's gonna be detecting it. So there's like 2 failure cases. Either you inject it, the process crashes, and someone like gets paged at 2 a.m., hey, this process crashed. Or the EDRs is gonna fire within seconds as it notices something off. Basically, the tool we're gonna be touching upon today is Ether. It's a specific injector built in Rust and C, which are aligned between an FFI boundary. We're gonna be talking about how you wrap something in C, how you wrap C, which has a lot of memory issue leaks, but is the best at doing low-level calls, functioning with the kernel itself, wrapping in something in Rust, which has the same low-level capabilities, but it actually has the error logging, and it doesn't let the tool deploy if it doesn't work for that specific environment. Shortly, who am I? I'm just like a low-level fanatic. Mainly my background is in software engineering and development. I'm kind of active in like NGOs or local DEF CON groups where we deal mostly with like software, hardware development. Also part of a CTF group for like participating in CFTFs and hacking. I have like background in technical work, but also like actually organizing kind of meetups and conferences myself, mainly on a smaller scale, but I do have experience in that. Let's touch upon the modern, oh, apologies. Okay. Let's touch upon the modern security landscape. Basically, as I mentioned a bit earlier, many of us still think that Linux servers are dead, they're unprotected, and once you're in, you're basically invisible. But no, we have many tools known as audit, which it logs the process creation, privilege changes, any syscall activity. We also have fnotify, which basically gives the kernel permission to access the file system before you can access it yourself. So it stops you from interacting with the file system before you can actually inject your process into it. Of course, then we also have eBPF. It's one of the more modern things in IT, which basically changed the entire field. Now, security vendors, they can hook directly into low-level kernel functions and protect ptrace, execv, and map without overriding a kernel module, and that changes the field completely. Tools like Falco, Pentagon, and other like vendor EDR, just any which come up to your mind, they're not just like watching the logs which we have, like a normal script. No, they're watching the actual boundary at the lowest level of syscall. So basically, it isn't like you just should avoid leaving files and forensics. No, every single syscall which you make in the system, it's being monitored against this type of baseline, which knows this is wrong and this is right. Basically, we have the Hall of Fame of traditional injection methods. These injection methods are the textbook ones. They're mostly the ones which are, documented and known, but of course, as any, they have their own issues. We have the most classic, it's LD preload. LD preload is one of the methods which it basically, you set an environment table and the dynamic linker to load your SO file before anything else in that process executes. Well, it's probably one of the most best techniques for actually getting your injection done, but it's incredibly noisy in the way just in the environ folder and proc/pid, it's obvious. Basically anything which cats that specific folder and grabs LD preload, you're immediately, caught. So it's simple, useful, but it's loud. You can't hide from it. Then we also have ptrace, which is basically the fire and forget method. It's mainly used through ptrace attach, where you inject into a running process, you stop it, you override its information pointer, and then you try and return functionality back to the process. But this is usually the method which corrupts the original process, as you got something wrong in your stack. And when the process crashes, the entire production crashes. Then there's also one in many like CTFs write-up where people just try directly into the proc/pid, basically to write directly into the virtual memory via its procfs interface. Basically, there's no direct injection needed into the process, but most of us, we don't have the privileges to do this to the file, and it still generates these detectable syscalls, which an EDR is trained upon, and they know this is bad. Basically, the problem is these are mature techniques. They've been used in the field for over 20 years, but at the same time, the blue team, the defensive measurements, know about these techniques for 20 years and created, tools to defend upon. And EDRs, these are one of the first rule sets they're kind of trained on. So, many classic injections fail today for a multitude of reasons, but mainly it's, first of all, we mentioned LD preload, it's really noisy. Then we also have the issue of the architecture. Let's say your injector, most injectors are built only for a specific architecture type. Let's say your injector is 64-bit, but you run into your target, which is actually 32-bit. Of course, a 64-bit injector can work against this 32-bit legacy process. There's also the issue, we know that most enterprise environments, they're a mix of architecture. You have maybe a 64-bit environment with this 32-bit SQL database. You also have the issue of like thread collections, mainly in ptrace. You enter the process, you have no idea what the process was doing before you interrupted it. It could have been in between a malloc call in C, and if you try returning it, you can accidentally free up memory space, which you shouldn't, and cause a crash in production, as I mentioned beforehand. We also have like the issue of RWX, read, write, and execute. If you try, for example, with ptrace and shellcode, that's one of the biggest heuristic indicators, which most EDRs will just flag them immediately. We already touched upon LD preload. It's noisy, and there's also like the thing that many high privileged targets or processes have this like already have a secure mode which immediately protects against LD preload. They don't even know it, they completely ignore it. We have the same issue, not the same issue for ptrace shellcode, but basically it could cause crashes if we don't know exactly the architecture or the information. So let's move beyond ptrace. We have many actually other methodologies which are way more modern. We have process VM, read V, and write V, which basically are like the key alternatives. They let these syscalls like let you copy data between user space memory regions of different processes directly. There's no attachment, no stage change, and no like tracer PID is gonna, so if you enter the prog PID status folder, there's no tracer PID. It basically is the same as before. But of course, it may be a key alternative, but it does have its trade-offs. You do need capsys ptrace, or like appropriate ptrace settings, which a few like specific distros or defense systems may protect against. So in those environments where these restrictions aren't restricting you from using this methodology, it's the way quieter, primitive, and just better. Basically, what Aether kind of focuses on is not just one specific technique. It uses ptrace when it can get away with it. It uses cross-memory writes if it can get away with it, or fully anonymous memory file loading. We also have something interesting. We can just eliminate the file on disk. We do this via mfd create. What we basically do is we create a file descriptor directly into the RAM. We inject it directly into the RAM. The kernel treats it like a real file. You can write into it, you can execute into it, but it has no system, but it has no path on the file system. Nothing in TMP, nothing in dev, shum, like knows that even it exists. And many tools such as Finodify and Inatify can't catch it. But of course, it doesn't mean it's completely invisible. In proc PID, like in the FD and maps, it'll show an entry of MFD, whatever the name is of the file, and maps will also show this like kind of anonymous executable mapping. The plus here is, of course, it's a bit more hidden. There's no disk on the file, and you can write your disk directly into MFD and then call a specific function fxv onto the descriptor, or like map it into the target's memory address as an executable segment. What's an interesting part is actually choosing the process which you're going to infect is probably one of the more underrated things of process injection. Basically, we can hit some process that's going to give us temporary access into it for maybe about 10 minutes. But if we infect the init daemon, which is known as the process always with PID1, you're basically touching the tree of the root file system itself. And there's also the fact that if you infect the init daemon, all processes, all child processes are like spawned from it. So meaning you indirectly infect all the other processes and you just take over the operating system. The attack surface, of course, increases even further with this. You have the dbus IPC, which you could attack on. The systemd as a whole, which is systemd is usually PID1 in most modern distros. So let's just introduce Aether more directly as an injection framework. Basically, it isn't like a single tactic script. You don't just have LD preload, you don't just have ptrace or MFD. Pick one and like hard code it and just test through these bunches of virtual addresses and see if they're actually real. Basically, you have this C layer. The C layer is the one which injects into which is the parasite which is injected into the code. It has these function calls, while Rust, as a language which of course solves the memory leaks of C, is the one which deals like the communication, does the calculation of the addresses, and if there's anything wrong, it won't inject, it will just abort the mission immediately. If we had an injector which was fully built in C, even if something was wrong during the process, it would still inject into it, it would crash the process, and we'd be, well, found. Basically, what the Rust does, the Rust and C, they communicate through an FFI tunnel, mainly through Rust and safe blocks. And at runtime, actually, Rust will be fingerprinting the environment, and it will check what the ptrace scope is, whether the BPF telemetry stack is visible, whether anything such as YAMA LSM is active, or other types of defensive measures. And then it'll choose the most definitive injection method, ptrace, or like around 20 injection techniques. Now we do have a bit of a problem again in the 32-bit and 64-bit. We don't just have the issue of it being a different process, a different type of structure. Of course, ELF headers, they're different. So basically, throughout with Aether, we just calculate the ELF if it's something which we can inject into with a 30-bit, 32-bit, or 64-bit injector. We also have binary layouts. Over here, on 32-bit, the first 4 registers, EAX, ESP, EIP, EBX, are far different than the first 6 register widths on 64-bit, ROX, RSP, RDX, RCX, etc. And in 32-bit, the register constraint, they are 68 bytes, while on 64-bit, we're dealing with a technology which is 216 bits. So imagine your 64-bit injector trying to write into a 32-bit process which only accepts 68 bytes. Of course, it's going to get confused, and the process is immediately going to be crashing. Let's just go directly into the C layer. Basically in C, as we mentioned a bit earlier, we're going to be avoiding... the C is like as minimal as it can be. We have no malloc, no printf, no memsp, which is pulled from the standard library. The reason is mainly that if you're in the operating system and you kind of inject with these libraries, their function calls are very known, and the symbols are very detectable. There's something which most EDRs, that's one of the first things which they are trained on. So of course, we're going to be trying to bypass libc entirely and use memory operations which use which use pointer arithmetic rather than the standard library calls, which most defense systems are trained upon. We also have how we have the function mechanism. The function mechanism is we have the PLT, which is the procedure linkage table, and the global offset table relationship. Basically, when we have a Linux binary call into a library function, for example, let's just say we have malloc from C. It won't go directly into malloc's address. Rather, it's going to be jumping into the PLT, which is this procedure linkage table, which is a read-only section of the binary. And then that stub kind of like reads a writable address from the GOAT, which is a writable section of the binary. The GOT then is going to be pointing straight at the function, and if the GOT is writable, we can change the pointer in a GOT slot. We can then like just make calls directly into the malloc. Rather than calling directly into the malloc, we can just make them jump over to our payload instead. Oh. Okay. I think we jumped over a bit. Yeah. Basically, we just mentioned the MFD without modifying the disk. Mentioned. Okay. We can just head over actually straight to the demo, I believe. With the tool, basically just entering, we can just search up Aether. Oh no, it's not even popping up. Here. Okay, so what we are doing right over here, we are calculating all the types of processes which a specific computer, let's say we have the initial access to this specific system. It's going to automatically calculate just all the running processes which are in SED, and it's going to tell you basically the user type, if it's root, whatever it is. We can then, let's pick this specific process, and we have around like 20 injection techniques. We of course have all the ptrace ones which we mentioned earlier, LD preload, and we also have maybe like the more quieter primitives which we have, which is process VM, write, and read V. So we can just go over to the second tab. Let's say we want to do something with ptrace attach. We can go over to the third type of section of the tool. Over here, this is kind of the automatic script. It doesn't actually say that the calculation, it's not calling the function call to happen. Just whenever you run the injection, it's going to be telling you the address which it calculated, if the FFI is actually functional, and it's going to be deploying that daemon. Another interesting feature of Aether is whenever you're in the process of injecting into another, if you're injecting into another process, a Rust daemon is going to be spawning, kind of infecting the init daemon originally, and it's going to be a watchdog over all the processes, and if there's a change in one of the processes, let's say a DL open or DL close, it's going to be recalculating the virtual addresses. So let's just go over to the fourth tab. If you press enter, you can see, bar loading currently is probably just parsing the specific file variables. Basically kind of just tells you if it's a success, and here we have the output. But this is just something running locally on my laptop. Basically it's this thing, it calculated the base, it deployed the daemon, which of course has the PID first. It's inspecting the daemon. It's going to be telling you that, okay, the FF5 is okay. If we jump over to 2, we can basically just see the daemon, kind of its health, if it's doing all right. If we jump over to 3, we kind of have like live patches. if we press, for example, enter here, we can just like do a try and do a hot reload and a restart. But basically, since the script already finished, there's no need to restart the script from originally. Basically, that's the function of the tool. Oh. So, in more technical terms, we have the way that okay, so basically when we wrapped C in Rust, we also had evasion as a kind of side effect of this strict FFI boundary. Many defense systems, such as EDR agents, they are trained on these specific library calls, function calls, the standard C and standard Rust, which they've started. But when you combine two runtimes at the same time, you get something which is fragmented, something which most defense mechanisms aren't, they don't know what it is. They're confused, basically. So it hits the boundary, and it's not like a chain call which is invisible. It's just something that, it's not a recognizable pattern, which makes it more difficult for the defense system to see if this is an issue which they should page someone about, let's say. Basically, most EDRs are trained on these specific data sets. The typical allocation patterns, typical C things, and Rust ones too. We, of course, though, run into issues specifically when it's coming to Rust, mainly into allocation. What Rust wants is immediately Rust, depending on the type of allocator which it has, it tries carving out its own memory into the operating system. That, of course, can kind of just expose us. And what if it tries, let's say, requesting memory from the OS and disrupting one of the current processes and try and manage its own heap? Basically, what we do is we call mmap directly with mmap anonymous and mmap private to carve out this like dedicated region into memory, so the Rust engine runs there before anything else takes over that memory. And then basically the host and the payload, they never share this space. They just go immediately, they just inject straight into the process. And basically, whenever the address, whenever the specific process dispositions or like cause like missing events from the injection, we say like the current signal state of the process with like proc mask. It continues running the operations and it just takes a detour and doesn't actually finish the script. Otherwise, we mentioned to Damien, it basically just makes sure the payload survives. The essence of Aether in its core is to show that process injection isn't something solved. It's something which is still a real issue against modern defense systems. The techniques are mature. It's just mainly that the toolings are also fragile. Mainly are just like C tools which are tested on a VM, and whenever they're used in production, they fail automatically. So I guess I just kind of created something which shows you that process injection is still something real, is still an issue, and we kind of need to shift the focus from defense systems of basically trying to define runtime analysis and memory analysis. We go into as low as we can into the kernel and try and do an analysis of that. Thanks a lot. That's Aether. Any questions? We finished a bit earlier
No worries.
than expected.
Yeah, we have our first question. Here you go, noble sir.
In your experience, how does does different methods protect? I'm thinking like Defender and crowds, and the different EDR solutions.
What was the question again?
When it comes to the detection
Yeah.
to these kind of attacks, how effective are different EDRs?
I mean, of course, it depends on the tier you're kind of on. If you're, for example, on many things like CrowdStrike Falcon, let's say for an example, this could be effective on the lower tiers for an EDR bypass, mainly freer pro tier, whatever the tiers of CrowdStrike are. Against actual enterprise environments, if the EDR is something which does only like audit logs for, let's say it checks if there's any files, it doesn't like it doesn't check the actual memory. If it doesn't check the runtime, this is a tool which can bypass that. But if it's something which, let's say it actually checks out the memory and the runtime, it's a dilemma if it's going to get caught or not. It just completely depends on the EDR. If they see this kind of call stack, which is unknown to itself, it doesn't know if it should report it or if it's just something, it gets confused on what to do. So it basically depends on the situation.
Okay, thanks.
Anyone else? Yes.
Hi, thank you for the talk. I'm
Over
on
there.
the other side.
Left.
This guy.
Oh,
This
hi.
guy. Hello.
Hi.
Thank you. So the let's call it information gathering you did at the beginning with your tool. The first step you did with your tool, where you enumerated all the processes and look at the techniques you can use. Is that something you could detect, or is it common that you have a process running around the look here and there?
Basically, what we just did there is just you just printed out all the running processes. Basically, maybe it's something which could be detected. It's just like, is it really something which is worth flagging if all your processes were just like written? It's not even calculating its memory addresses. It's just something which is written out.
Okay, so you're basically running PS.
Yeah, basically, yeah.
Okay.
It's not something which usually gets detected.
No, of course. Thank you.
Yeah.
Anyone else? Raise your hand. Firm and high to the skies.
Oh.
No? Sure? Okay. Thank you very much for a nice talk. And in similar fashion, you're free to go for a bit. We're going to start. Find your seats. Is everyone doing all right? You found what? Perfect. It's yours now. Yours to keep. Okay, we're going to kick things off. So we're going to have some interesting insights into running a cert thing. So please help me welcome Adrian and Michael.
Perfect. Thank you. So we should be good to go. Perfect. Thank you. Hi, everyone. I'm Adrian. Here's Michael.
Hi.
We are here actually for the first time, so we are really glad to be here. Thanks for having us. Thank you. And we will be presenting maybe something different, maybe more something from the defensive security and proactive work that we are doing in public sector in Slovakia, so offering some services to public organizations there. Just to quickly introduce ourselves, I work as a threat intelligence analyst, also an engineer at the Aphrodite project. You'll see what that is just in about a few seconds. And also I am a MISP administrator, where maybe also I hope some of you know what the MISP is, or the MISP tool. And Michal is our CSIRT lawyer, a university researcher, and we'll be covering also technical stuff, but also some legal stuff about how we approach the problem we'll be presenting. So yeah, the stage is now yours.
Okay, so thanks. Some words on our organization, on our CSIRT unit. As everybody, I believe, knows, CSIRT units are all over the world, so each of the countries supposed to have a national CSIRT unit. We are governmental, so-called sectoral unit, so our constituency is basically built around public administration. We have two locations in Bratislava, where we are coming from, that's capital of the Slovakia, and the second one on the second part of the country is Košice, where is the second location. Like small fun fact, Košice is the city where Volvo is now planning to start up its manufacturing plant. So this is Košice. Košice in Bratislava, it's a capital and the head of our CSIRT unit, but in Košice we have a laboratory for hardware and software and forensic analysis. We are active in international cooperation, so we are part of the first TF CERT. We're communicating also with ENISA and all our partner CSIRT units. We are also active in cooperation in various universities, also in Slovakia and the neighboring countries, security services, police, intelligence services. Okay, to more introduce you in specialties of what used to be a CSIRT unit in government, you have to understand what the constituency is. Even we are a very small country, so we have like 5 million inhabitants. Our constituency is the biggest in the country, so we are covering more than 8,000 constituents, very large, heterogeneous bunch of entities coming just from the small municipalities and their organization up to the ministries and central authorities. So very, very nice and very different authorities with a different level of cybersecurity maturity. Okay, what makes us special is that when we started our activities, it was like back in 2009, we was offered and we were based also on the special legislation, which makes us we have more powers based on the special legislation. So it's not the Cybersecurity Act, but it's a special legislation on IT in public sector, and it covers also the cybersecurity of IT in public administration. So as Adrian introduced ourselves, today we will cover more the preventive, proactive part of the services that we offer. But as you know, CSIRT units, they offer all of it. So not just the preventive, but also the reactive services regarding mainly with the incident handling. But what we do also the reactive part of the services. But what we will cover today, it has a strong relationship with all our services. So CTI is like something, I would say, like a red scan that comes just from the monitoring, scanning, and can enrich all of our services. So now it's time for Adrian to go into the core of our presentation, and Adrian will guide you throughout Aphrodite as our new CTI platform.
Perfect.
So, Adrian, please.
Thank you very much. Okay, so let's get back to the technicalities. Let's lay out 5 use cases for our CTI system. And I want you to remember them as best as you can, because we will get to them later and we will reflect on those. So the first use case is pretty simple. You have organization, and on the other side you have a CSRD unit, us. Mainly it starts with an incident. Organization has an incident, any kind. They have to report it. I think they are obliged to report it to us if they are part of our constituency. We are handling the whole incident handling process, and after some time, when the incident is solved, we request some IOCs. We would like to know some specific information. Maybe we can share, we can import it to other detection mechanisms. Well, maybe you can guess what kind of format you get. You get a nasty TXT file, yeah? You get a raw, unprocessed data that you would like to have structured, but that's basically everything you get. So you have to additionally process these data. What's the use case number 2? Once again, it starts with an incident in an organization. They report it, we do the incident handling, and after some time, now we want to collect those IOCs. We go there, we collect those, and the question now is, where do we store them? Effectively, of course. It's not only about us, it's about, of course, many organizations in public domain in Slovakia. Maybe you can guess where we will store them? No, in a TXT file. Well, up until now, of course. You'll see in a second why. Third use case. Now, we are the ones that we discovered some new IOCs, and we want to share it with the community, just so, once again, we can enhance the security for them and for the whole country. So we will send them an email. This comes from us, so we don't send them a TXT file. We are trying to go at least a JSON way. So yeah, we'll send an email, and it's okay to send an email to 1, 2, maybe few organizations. But what happens when you have hundreds of them? You have more. Well, that basically means that you have to do an extensive emailing, some other processing. You have to specify these IOCs for many organizations. And that generally leads to crying internally. Use case 4. We would like to share IOCs from our incident with the community. That now comes from the organization. So they have an incident, they want to share those IOCs. Well, of course, they send us an email with a TXT attachment. And just from this information, I know that I will have an extensive emailing in front of me, so I once again cry internally before doing that extensive emailing. And the final use case is organization would like to have more context about their IOCs. They get just a list of data, IP addresses, hashes, domains, and that's it. They don't know what it is about. They don't know if it's malicious at all. So once again, they email us a TXT attachment, and our response is, sure, let me spend a few hours on it, like I have nothing else to do. So these use cases basically explain the problems we had before the Aphrodite project. And what it is, let's explain it right now. The Aphrodite project is a group of interconnected MISP instances and external tools and platforms. Has any of you heard or worked with the MISP tool? Maybe you can raise hands. Perfect. So you guys know how it works. Currently, it's only available to government and public sector, But we'll get to that later because there is a potential to go even beyond that. It's a trusted environment allowing organizations mainly to store and share IOCs, enrich them, and also validate them. And we can call it like a building block for the CTI because from what I know, this is the first of its kind in Slovak public domain, this project. It's a part of a bigger project called EWS, Early Warning System, which includes not only this is only the CTI part, but also includes vulnerability scanning, XDR, just monitoring generally. So this is just a smaller part of that. Okay, let's look at the actual composition of the Aphrodite. There are 3 MISPs currently, 3 MISP instances. The first one is called Aura, which is our internal MISP, where all the processing happens. It's basically the brain of the project. Then we have MISP Athena, which is connected to government SOC, where all those processed IOCs get uploaded to government SOC to monitor every organization in the public domain. And then there is the access layer for organizations, which is MISP Aphrodite. They can access this instance 2 ways. First one is direct access. Of course, MISP is still, or this instance is still a MISP tool, so we don't want to strip these organizations from the basic MISP functionalities. So they still can request direct access, and they can utilize these functionalities without having to get their own instance. We understand that not everybody has the means to do so. And then, of course, they can, if they want to, if they have the means, to create their own instance and synchronize it with Aphrodite. This is still covered in our governmental network, so we call it GovNet. How is it laid out? What's the infrastructure for that? May seem a bit overwhelming, but it's basically pretty simple. On the left side, you have the Aura, which is the internal MISP, which even visually you can tell that's some kind of a central part of this project. And on the right side, you get Athena, which is directly then connected to governmental SOC, as I said. You have Aphrodite on the upper side, which then connects to organizations. And really integral part of this project are also other external tools and platforms. For example, Threat Intelligence Console. As I said, organizations can enrich their IOCs to get more context, and they are doing it. They are basically can outsource these processes of enrichment by uploading their data to Aphrodite and enrich it through our MISP, which is then connected to Threat Intelligence Console. Apart from that, we also have connection to external MISP communities. So it's not only us, but it's also NATO MISP, FIRST MISP, and then European MISP, which is more used for temporary correlation, but still it gets we can get the context out of it, additional context. And last but not the least, we have connected the XDR console to monitor different organizations with agents directly their devices. So this is basically the whole infrastructure for Aphrodite project. Of course, there are tools and platforms, as I said. Our main CTI tool is currently Recorded Future, but also we get some interesting data from SOC Radar, and we mix it with Trend AI, which is responsible mainly for the XDR part. And on the right side, you see those MISP communities I was talking about. That sounds perfect so far. Yeah? You get a lot of data, seemingly. But is that it? Is that everything you get? The answer is no, of course. You get more. You get structured IOCs and TTPs. And the sharing and delivery is ensured both ways, of course. It has to be regulated somehow, and we are using TLP and PAP protocols for that. Organizations have an opportunity to outsource IOC enrichment. As I said, they can upload their IOCs and enrich it through our threat intelligence platform connection. They get regular summary of events in the cyberspace plus those IOCs. So we also do the proactive work. It's not only that we get data from other external tools, we also do the work ourselves. We gather them into Aura and publish them outside so they can get more and more IOCs on a daily basis, basically. But also, apart from that, they also get a monthly CTI report. So there's already a bunch of stuff getting out to all of these organizations. They get direct alerts in case of data leak, mainly credential leak. Recorded Future and SORGRAD are really helpful there. We are trying to warn them ASAP so they can avoid being the target of maybe some credential leaks and credential theft. And they get threat feeds, of course, which is basically just a big list of IOCs, also with some context. And they get streamlined connection to government SOC. So basically, when they upload something and they decide to share it with the government SOC, they can. And it's, in a matter of seconds, it's delivered to government SOC, which then they can import those IOCs to monitoring devices that monitor the whole public sector. They are not helping only themselves, they are helping other communities in Slovakia, public sector, to prevent any possible threats. Oh yeah, and of course, correlation environment for CTI data. As I said, MISP is still MISP. So the correlation is a big part of that tool. About the uploading, enriching, manually validating, we will get to that process basically right now. I would just like to mention that we have a custom taxonomy for that, which consists of currently 5 tags, which is not much, of course, but it gets the job done. And we strive to achieve full automation in this direction using cron and Python because the enrichment process is actually pretty easy to automate. The validation is a little bit more difficult, but we'll get to that right now. So as I said, we have our own taxonomy in MISP. We have request tags, and then we have basically response tags. The request ones are this is the default one. Every event that is created in MISP Aphrodite gets this tag by default, so that you just know that this event is being processed, organization is uploading their IOCs, giving the context, and much more. Then they can request validation and request enrichment of those data. And the enrichment will be a really good example to explain. So these are the request tags, and on the right side, these are the response, basically, tags. The first one, request finish, basically says that, OK, your request is done. You can request more, or you can finish the event. And even finished, the last one, last tag is saying that, OK, this event is done. We can publish it, and we are happy with that. So let's look at that enrichment process. We have 4 points in that process. The first one is the user, the organization, of course, which has direct access to Aphrodite. Aphrodite is connected to our internal MISP Aura, and from that we can enrich data using Recorded Future. First step, pretty easy. They upload those IOCs. And of course, they have to request that enrichment by adding the request enrichment tag. The second one, Aura detects new events with the enrichment request tag. We are using automation for that, so they are basically checking periodically if there is a new event with this tag set. If there is, Aura automatically downloads it and starts the enrichment process, which is basically just API communication with Recorded Future platform. The enriched event is then returned back to from Aura to Aphrodite. We, of course, don't want to create duplicities. So in Aphrodite, the already existing event is only updated with new data. And of course, the organization then sees the enriched event under its distribution group, and they can use those data any way they see fit. So yeah, as many other projects, also this one has flaws. It's not a perfect one, and it's a pretty young one. So we are refining it constantly. It's a continuous process. The first one is, of course, persuading organizations to share their IOCs. It seems like an impossible task sometimes, but we are getting there slowly. Continuous requirements to fix bugs. It's basically a software development at some point when we are working with Python and maybe bigger scripts. So we need to fix bugs essentially a lot of times. And yeah, tag consistencies can be a nightmare, but that's a self-made problem because tags weren't supposed to be used that way as we are using those. I don't think the developers had that in mind for those tags, but we decided to go this way anyway. It's currently fixable by thorough tagging. So remember, guys, yesterday it was drink responsibly, today it is tag responsibly. But let's get back to those use cases. Let's go full circle. Let's go back to those use cases from the beginning. The first one, if you remember, could you send us IOCs from your incident? That way, and before this project, it was a problem. Now it isn't. Sure, we already uploaded them to MISP Aphrodite. Just log in, you got it there. The second one, where do we store those? Once again, MISP is really good with working with IOCs. So we just upload it there. You have a structured data with context. You can enrich it so you can get more context and more information, and you can effectively share it between other organizations, which makes it basically more sustainable than just extensive emailing. We got new IOCs regarding that phishing campaign from yesterday. Perfect. Publish them in MISP Aphrodite for the whole community. So the sharing is much more easier. If there is an organization that wants to share incident IOCs, that's basically the same thing. They just publish it in MISP Aphrodite for the whole community. And if they need more context about those IOCs, they just request enrichment. And if we are feeling good, we can validate it for them as well. And you get rid of all those nasty text files, extensive emailing, and internal crying, which is perfect. We also got approved by the MISP gods. So yeah, guys from circle.lu, which are essentially creators and developers of the MISP tool. They actually went through some of our events, so we know that we are, let's say, doing a good job, and we are happy for that. So we know we are going the right direction. So that's about the technical stuff. Let's get back to small legal stuff, and
yeah, now the legal stuff. No, don't be afraid. I will not bother you with the legal or legal lecture. I will just very continuously speak about what Adrian said. The first of the flaws was to persuade those entities to join us and join and share the IOCs. So how to do this? You know, what was the first step was to facilitate the relationship between our platform and those entities. So from the broader perspective, all the European Union legislation coming from the NIS2 to special regulations like DORA, etc., is at the end of those acts, but when you read it until the end, they are pushing the what is called information sharing agreements. So the member states and the entities are challenged with CTI sharing already. So we build up on that and we come up with the agreements. As Andrew and Adrian already introduced our early warning system. This is part of it. So we have those who are members and are participants in the early warning system, their agreement already includes the clauses that provide for and facilitate the information sharing. And then with those who are not even in our constituency but are willing to join us, and they see that we are doing a good job and they want to share and also to get the information from our MISP, for them we have developed a memorandum of cooperation, not big stuff, just to have a clear understanding and clear agreement on what's going to happen. And so, of course, because there is a lot of, not just the security, but also the GDPR and so on, so you can imagine that you have to cover somehow all this stuff. So this is one thing. So how to cover up the sources. So as you can see, we try to have a lot of sources, not just from our own activity, but also from the commercial suppliers and, of course, from the agreements with different entities. Then the second legal stuff that had to be done somehow was, okay, so we have a very nice project, good one, technically rising up, but needs also certain terms and conditions, so how to build up about this. So we come up with I would say, very easy terms of use, just easy to read, nothing that would just see you stuck on the time on learning and reading that, but saying very principled things. We offer our services based on the registration. So the registration is the first step that we had to cover throughout the terms. The account and how the account is established. Of course, responsibilities. So we just simply said what is acceptable use with what you got from our MISP and what it's not, what's forbidden. We also covered up the rules for uploading, and also we just want to put something about the MISP to MISP, so this push way of how to use our services, small part of data protection, and of course when something bad happens, so you won't have some kind of ways to terminate the relationship with the participant. So this was the legal part that we had to cover somehow. I believe that it's functioned so far good. So yeah, legal background. And then, of course, the second part of the, I would say, PR of our platform is that we know that those guys sitting in the entities, they know the technical advantages, but we, as a part of the, I would say, PR, we are covering also the legal understanding of why to use MISP, why to use our services, and it is the compliance support. So, as I told you, when it comes to NIS2, when it comes to local legislation covering the cybersecurity, all the security measures and obligations coming from detection, monitoring, risk management, up to incident response, it all can be supported via IOC sharing. So when it comes to better detection, when it comes to better enrichment of incident reports. As far as you know, I believe NIS2 came up with certain timelines and deadlines with incident reporting, so 24 hours with the early warning, 72 hours for notification, when you are obliged in these given time frames also to cover up also the details of the incident, including IOCs, including TTPs, including all the, I would say, signings of these warning signs that are and could be used in future for not just solving the incident, but also to identifying the threat actor. So this is something that we somehow try to manage. So the technical, also the legal part, just to persuade those people that, yeah, it makes sense to join us. It makes sense because we are not threatening you by any legal, I would say, legal tools, but we want you to see that even from technical and even from legal part, it gives you only advantages. So this is from our part. Yeah, please, Madrian, follow on.
Thank you. So let's look what the future holds for this project. As I mentioned, right now we are currently offering these services only to public organizations and government governmental organizations in Slovakia, but we would really love to create a fourth MISP instance that will be completely public. So not only for private sector in Slovakia, but maybe even for other countries, wink wink. So yeah, we would really love to do that also in some time. Cannot tell you when. We need to optimize automation. That goes without saying. And of course, advertise the Aphrodite project. We have some organizations, but we are not there yet. There are far more organizations that maybe didn't even they don't even know about this project. So we have to do better. And possibly integrate more tools and platforms just to make the output robust and diverse. Because, of course, you get context from one threat intelligence platform, perfect. You get that same output from 3 intelligence platforms. Of course, it makes it more, at least I think it makes it more credible. So to summarize quickly, the Aphrodite project, it's an environment for CTI and threat intelligence sharing using tool MISP. Organizations can enrich, they can validate their data, and therefore add more context to it so they know what those data even mean, not only plain text IOCs. Organizations receive proactive warnings from our work, but also from our integrated threat intelligence platforms to improve their security. And prevention mechanisms, Aphrodite instance is accessible 2 ways, directly or using your own MISP instance. And of course, solution is scalable. We already tried to integrate it to our other projects like Achilles, which is connected more to vulnerability management and scanning and other vulnerability-related things. So we would really love to do that fully. Thank you very much. I think that's all for the presentations.
And we do have time for a few questions, because there will be a taxi waiting for these guys to leave us. They're running away. So anyone? A quick question? Now I scare you away even more than before. No one? There we have one.
Okay.
Yeah, one. Perfect.
Hello.
Hi.
Thank you for the nice
presentation.
Yeah.
Thank you so much.
Great work.
How do you work with like the smaller, like local government organizations that don't have like enough space in their budget or so to actually work well with the MISP? Do you use the like direct link?
Mm-hmm. Yeah. Great question. I forgot to mention that this is all free, of course. So they don't have to have a budget for that. Since we are offering our services, I think it's also legally that we are offering those for free. Yep. Because the background just says that we are supposed to inform these organizations just because of the law, how it's written. So first of all, they don't need any budget for that. This is completely free, and if they don't have technical support, which can work with MISP, we created at least some information lists to provide basically manuals to do the basic activities in Aphrodite. So it means uploading, enriching, and validating their data. If we are a smaller team, so when there is a possibility to help them directly, we try to do that as much as possible. If not, at least those information lists are sent to those organizations to work with those.
Okay, I think we can do one more question if we have one. Okay, then thank you very much, Adrian and Michael.
Okay.
And Okay.
All right.
Hey, it's time again. We're back.
I hope you guys had some good lunch. Did you? Nice. As did I. And I found this thing.
What's in your hand?
It's a Hugo. It's I could fall in love with an orangutan in this thing, but it's quite lovely.
What do we do when we drink?
What?
What do we do when we drink?
We say Assad.
Assad!
For everyone who was here last night, anyone who wasn't, that's going to fly right over your head.
Yes. But we want to do a special announcement.
Yes.
Me and Johan is getting married. Just kidding, we're not. But there is, like during the coffee break, like after the next, not this talk, but after that talk.
At roughly 3:40.
Yes, better put. Yeah.
Thank you.
Yeah. So then we're going to do some award ceremony things. So don't leave, because there will be...
You know, CTF prizes,
candy
hacking
and
award prizes.
So we're going to sort of bundle that in.
Yeah.
During the coffee break.
Who's that guy?
I have no idea what the guy is here for.
I don't know. Me either.
Maybe it's our replacement.
Got a retro
Kill it
t-shirt.
with fire, man. No, I'm just kidding. Okay.
Fair enough.
We're here.
We're here.
Yeah, we made it. And please help us present or welcome the next speaker, Claire.
Come on stage. Thank you.
Hi. Hi, I'm very happy to be here to talk about video surveillance networks. My name is Claire Vachereau. I'm a pen tester and researcher at Orange Cyberdéfense in France. And my specialty is penetration testing OT systems, and more generally, not IT, including video surveillance networks. So these systems involve the devices, the components that are used to capture, display, record, store, or whatever, a video stream. And this stream can be used, for instance, to monitor a process or part of a process, but most of the time they are used to monitor and detect intrusions within or around the facility. So compromising them is usually a matter of safety and security as well. There are, of course, different types of video surveillance systems, including different types of devices, depending on the functions. And different types of systems can interact using different means, but here we are going to focus on only one, on IP-based video surveillance systems, and more specifically, the one that comply with the ONVIF standard, which is actually the main standard for this purpose. Okay, so here we are doing a penetration testing assessment. So when we are in this situation, we usually start by plugging on a customer's internal network. And most of the time, we are starting from the user VLAN. And from there, either we unexpectedly start encountering video surveillance components, or we can also actively look for them. So pen testers, including me, of course, usually know how to interact with this device, but they do not always use specific components of these services and specific functions of these devices. So we are used to use standard IT services such as the web interface, the FTP, the SSH, and so on. So first, we are going to talk about some of these specificities and see how we can use them to better discover and interact with these systems. And this will lead us to the video stream itself, which is the center of these systems and, of course, of this presentation. When I started this research, what I wanted to do was to see how we could do the attack where you intercept a video stream and replace it with somewhere else. I wanted to see how it could apply to pen test. And when I did that, I discovered that, of course, there are many well-known attacks and so on, but I discovered that they rely on prerequisites that are not met most of the time during pen test. So we are going to see how to overcome as much as possible this difficulty and hopefully make the attack work. And you may not see, but on stage there's a live demo. So I guess it's time to start praying for the demo gods. OK, so first, let's find our network surveillance components. So during an assessment, unless we have been given a map of the network, we don't know where these components are. So we'll start looking for them. But whether we will or not find them depends on how the network is organized, of course. If it follows the state of the art, we should never be able to see video surveillance component from a user VLAN, because then it should be in a dedicated and segmented network zone. But you can imagine that this is usually not what we see. It's very common that they are mixed with other types of components covering other functions. For instance, it can be mixed with OT, building management systems, safety, such as access control, things like that. And by mixed, I mean either on the same VLANs or different VLANs, but no segmentation, and so on. OK, so I see this a lot, but the thing I see the most is this configuration, where video surveillance components are mixed with everything else. So this means that from our starting position in the user VLAN, we already have a direct access to them. So this is what we are considering here in this demo, of course. Another thing I want to mention briefly about network organization is that these systems, these networks must also be segmented internally by trust zone, for instance, what's inside from what's outside in public zones, by type of components, and so on. But I've only seen this once, and usually everything is just mixed once again. So since if you reach one of these components, you reach them all. So again, this is the situation we are considering here. OK, so how do we find our devices? Well, the most obvious way is direct unicast network scans using Nmap, targeting standard IT protocols and specific protocols such as RTSP, which I'll talk about later. But yeah, you know that. That's not very OPSEC. Another thing that works fine with on-VIF components is that many of them understand zero-conf protocols, at least one zero-conf protocols. So this is a very useful way to discover this kind of devices. Just to show you, I have written a small Python script that does zero-conf discovery using SSDP and WS discovery, which are two zero-conf protocols. So I'm going to show it to you, and it will allow me to introduce the setup first here. So, OK. So we are trying to make sure that nothing happens to this piggy bank. So that's why there is a camera pointing at it. I'm trying not to think people, sorry. So this is our main camera. I also have a security guard station, so that the security guard, the viewer station, so that the security guard makes sure that nothing happens to the piggy bank. OK, just one moment. It won't stay in place. OK. Right. OK. So all of these are on the network. I also have, on the same network, my attack laptop, of course. And I have an additional virtual server for network things and with video management software as well. So as I said, I will run my script. What it does is that it will send a few multicast requests for SSDP to discover different types of devices. It will do the same thing for with WS Discovery. WS Discovery is web service discovery, by the way. And we can see that we have a few results. So this one is our server, the virtual one. This one is the axis camera, which I used to present the setup. And this one is the main camera, which is a Pelco, and which is the main camera monitoring the piggy bank. Okay, so with this means that we have already discovered all video surveillance-related components on this small network. So it works fine. It has good results during penetration tests. The only quite big limitation can be that it works only if multicast is routed, of course. Okay, so that was for the introduction, in a way. So now that we have discovered these devices, we will try to access it. These devices have management services, like we are used to, like web interfaces, FTP, and so on. I am not really getting into details here. You know how it works. It has common flaws, as usual, default or weak credentials, and encrypted protocols. They can have vulnerabilities that can be exploited, and so on. An interesting service for management is this one, is the OnVIF web service. It's used by OnVIF supporting software to gather information and to configure OnVIF devices. So this one can be pretty useful during a pen test to have information on a device. It requires credentials, normally, but I've seen it unencrypted, so it may work this way. So to show you, once again, briefly how it works, I have written another small script that does a few GET requests on the cameras. I only do GET requests, a few basic GET requests with information required during pen test. There are many, many other things to get. And I did not do any set requests because during penetration tests, we try not to break our customer's environment by randomly changing settings. So I'm not doing this. So we will run it on one of the camera. This one is use HTTPS, which is a good practice. And I set myself these credentials to stick to the reality. And you can see that we have quite a few information. I will run it also on the other camera. This one is not encrypted. This is the default credentials, but the camera is older, but that's why. Let's say this is why, at least. So this one takes longer, but we'll get back to it later with the details. Okay. So this is for the management services, but we are mostly here to see the video itself. So we can view it usually from the web interface. There's usually a live view. But the main protocol that is used in OnVIF environments is to transmit the video is the protocol RTSP, usually on port 554 TCP. How does it work? So when a device wants to retrieve the video of a capturing device, such as a camera, it will initiate a session to this camera using RTSP. And in return, the camera will send the video data in a network stream. And this protocol is unencrypted. So everything goes in clear text. There is an encrypted version of the protocol, or several, maybe. But I've never seen them implemented in real life so far, so, well, we won't do that. Just to show you how it works, for those who are not familiar with this, we can just use any media player, and we will open a network stream. And we can read it. So, as you can see, this requires credentials as well. And then we can view the live stream here. Right. OK. So As you can see, it requires RTSP. Again, I've seen it unauthenticated quite often. It can also have default or weak credentials, and these credentials can be brute force. For instance, there is this very useful tool called Camera Radar that can brute force RTSP credentials. By the way, RTSP, the authentication mechanism for RTSP and the OnVIF web service are not the same, so the credentials can be different, and it's not because the authentication is enabled on one side that it's enabled on the other side. Okay, one other thing you might have noticed is that when I access the RTSP stream from VLC, I use a special path to access it, which is called a stream URI. And this one can be quite painful to find during penetration tests because it can be different depending on the vendors and the models, the configuration, and so on. So it's not very easy to find. So I use the first one. The second one is for the other camera. And I put some other examples of stream URI you can find. So basically, it's like credential. It's hard to find like credentials, or not hard, depending on the configuration, of course. How do we get it? So the legitimate way to do it is by using the OnVIF web service. If you have noticed, when I did the OnVIF discovery, I retrieved this information. So this is the right way to do it and the easiest way. But of course, you need to have the OnVIF web service credentials. We can also find sometimes the stream URIs in user manual, but not that often because users are not supposed to know this information because they are supposed to use the software to access it. There are also very big online databases with a lot of stream URIs that can be used. And finally, for simpler paths, the tool Camera Radar that brute force RTSP credentials can also brute force RTSP stream URI. Okay, so now we know how to access the video stream legitimately, but let's see what more we can do, of course. Oh, yeah, first I wanted to show you this. So do what you want with this information as long as it's legal and ethical, and you should also unplug your own surveillance systems, by the way, if you maybe. Okay, so what we are doing now, what we just did, is we initiate a session with a camera using the credentials. It's independent from all other sessions established with that same camera. We can establish many sessions. And the only thing we can do is retrieve video streams. So that's good, but can do better than that. If we instead intercept a legitimate video stream running between a camera and a viewer, we have two benefits. The first thing is that we don't need to know the RTSP credentials and the RTSP stream URI because the traffic goes through our laptop, and it's encrypted, so we see the video data already. So that's interesting. And the other thing is that since we see the video stream, we can also modify it. Yes, the only thing is that since we are doing network attacks and tampering with video streams for security, it can have a quite important impact on availability, traceability, safety. So it must never be done in a sensitive environment. But here we're not in a sensitive environment, of course, so we are doing it. What we will do next is we will first intercept the video stream. Then we will see how we can view the intercepted stream on our attack laptop. And spoiler, this is the most difficult part. And finally, we will see how we can tamper with the video stream. What we will try to do here is to do the looping trick, meaning that we will record a sequence, a video sequence, and then we will replay that same sequence in a loop and send it to the viewer instead of the legitimate stream. You probably have heard about this technique. It's quite well known. It has some history. You may have seen it in movies, first of all. This one is very nice. But, well, it's a movie, so they did not really care about the technical details. 10 years ago, Van Albert and Banks demonstrated it at DEF CON. They used a physical device that was plugged directly on the Ethernet wire. It gives amazing results, but it's quite hard to reproduce during a penetration testing assessment. Myself, I have written a tool a few years ago to do that with my colleague Nicolas, but it's not that good, so it's not public. And also, you can find tutorials online or in books that can have this kind of technique or other techniques targeting RTSP. And I like this one. It's a very good one in the book Practical IoT Hacking. But my tool or any tutorials I've seen online, none of them can be used during a penetration test. And I will explain why in a few minutes. But first, we will intercept the video stream. This is really the easy part. You can use any man-in-the-middle technique and tool you are familiar with. Here, I just stick to the basics. I do ARP poisoning with EtherCap. So I will do it between the Pelco, the main camera, and the viewer. And I must mention that I used a Pelco and an Axis camera, but what I'm doing here is completely independent from the vendor, so it's not a matter of a vendor. Okay, so we can see that there are a lot of things going through us. This is actually the video data, but it's not very practical having it this way, so of course the next step will be to transform that into a video. So there are probably several ways to do it, but what I chose to do was this solution. So I intercept the stream. When it's on my laptop, I will duplicate it. I will forward the original stream to the destination so that the viewer does not know I am currently intercepting the traffic. And in the meantime, the duplicated traffic is redirected locally on a local socket so that I can open the stream arriving on that local socket from my media player. Okay, so of course I wrote a tool to do that. Unlike the previous one, it's not in Python, but in C, because Python is not, say, optimized enough to handle the bandwidth of a video stream. And also I like C. Okay, so we'll do that. Is the stream still up? Yes, very good. So I will need just a quick information. I keep the destination port so that I can just filter on this port to make sure I get only the video stream. And also I use the same port as a local stream, as a local socket, for the local socket, sorry. And now I will run my script. So between my Pelco still, filming the piggy bank, the viewer, on this port, I use the mode redirect, and this option is to tell it to do the man-in-the-middle attack directly in the program so that I don't have to run EtherCap on the side. So what does it say? It says that packets will be redirected locally on this port. We can check that. It's better. That's me. Yes, we see that there are things arriving. So this means that we may be able to open it. What port was that already? I don't remember. Okay. But, so, it loads, but it will keep on loading and never open anything. And that's normal. This is because how RTSP works. So when you actually initialize a session with using RTSP, before sending the video stream itself, the camera or capturing device will send the information required for the viewer to understand the stream and to be able to transform the data into a video. So this includes the video format, resolution, frame rates, and many, many other parameters. So it looks like this. This information is carried in a special RTSP frame. It's in a format called SDP for Session Description Protocol. It looks like this. And by the way, you can also export it as a file and feed it directly to the media player. So this SDP thing is the reason why we cannot use the previous tools to do what we are trying to do during penetration tests. So the tool I wrote a few years ago does not work if we do not catch the RTSP session initialization, including this SDP information. The good tutorial I like from practical IoT hacking also captures this RTSP session in it. But here we are on a pen test, and we are testing systems normally that are running 24 hours a day. So probably the sessions we are targeting have been established long before we arrived. So there's very low chances that we will see this SDP and any other RTSP info session. So what do we do then? We still need it. So there are a few ways to retrieve it. So we can try them depending on the situation. The most straightforward way is to initialize another RTSP session, an independent one, with the camera. We retrieve the SDP, and then we can use the same SDP on our intercepted session. It works. Another thing is, well, I read in the RFC that special blocks can be sometimes included in the frames carrying the video data. And these blocks would include the video information. But none of my 4 test cameras from different vendors implemented it, so this is theory, I don't know. And the last thing I could think of is to forge a SDP file, to create one from scratch. It could be possible for standard formats, such as MPEG, but the standard I meet the most are H.264 and H.265, and this one include additional parameters. You can see, for instance, this very weird string at the end. It's generated from a combination of many, many parameters. So in theory, you could forge one, but there are low chances to find the exact set of parameters that would match a specific video configuration. But still worth trying. So here, we won't do that. So we will just establish another session with the camera and retrieve the SDP as a file. So of course, there's a tool for that. Once again. Up. Oh, come on. Sorry. OK, so it looks like this. I will just need to do one additional change to this. I need to tell it where to read from locally. So I set the port. And if everything goes well, I should be able to open the stream. It's demo, of course. So apparently it does not. Did I mess with the port? Sorry? Ah, that's why. Okay. Mm-hmm. That's unexpected. And of course, the session is down, so. Okay, back on. Sorry for that. Hopefully we have time. So now there's a new port, so I need to change it. And it works. Thank you. Okay, so that's one part of it. I'm not done. There's still one chance to fail. Okay, so now we catch the video. We see the video locally, but we don't tamper with it. So this is what we'll do next. So the idea is very simple. We record a sequence first, and then we will replay that sequence. This is what we will send to the viewer. Technically speaking, RTSP is in fact a combination of three protocols. There is RTSP for session management and for to control the video, like play, pause, and so on. There's RTCP that sends regular checks about the video. And the video data itself is carried in RTP frames. So this means that technically here, recording a sequence of video actually means recording a sequence of RTP frames. So this is what we will do. But of course, it's not just as easy as just recording a bunch of frames and then sending the same frames over and over again to the destination. RTCP is normally on UDP, and so that the media player knows in which order to read the frames, the sequence number and the timestamp carried in each RTP frame. So if we just send the RTP frames over and over again as is, of course, at some point, the timestamp and the sequence number will go back in the past, the stream will become inconsistent, so the video stream will stop on the media player. So it's not a very big issue, but still we have to overcome it. There's probably several probability, but what I chose to do was to keep the header of new RTP frames coming on my laptop, arriving from the camera. So I'm keeping the latest RTP frames header, and I'm just replacing the content of the video data with the one I recorded previously. Now it's demo time. Is it running still? Yes, good news. So first, I will need to end the previous attack. And I will use the exact same script, but this time I will use the mode replace, and I chose to record this amount of frames. This may have side effects because there is a lot of lights on stage, so it depends. So we will see what it does. So currently, as you can see, it's recording the stream to be viewed later. And yeah, now it's done. So it should be replacing currently the video stream with what we have recorded previously. So now, I don't know for now, but the attack should work. It's just that I don't see it. So this means that we don't need to care about all the SDP thing. I will just open it, of course, so that we can see what's going on. Right? And at the same time, I will open the other camera stream so that people who do not see the viewer workstation know what's going on the viewer workstation. OK, and now, if everything goes according to plan, I should be able to steal my own piggy bank. Thank you. I'm as surprised as you that it worked. OK, so that's it. A quick word about the remediation, of course. The best remediation I can think of is network segmentation. It's better if no unauthorized user can reach these, let's say, critical systems. It's also better if the credentials are not admin-admin. So harden your configuration, enable security features when they are, of course. And it's also better to upgrade to the secure version of RTSP, but I know that it raises compatibility issues with other devices on these systems that are older, and that's why I've never seen them implemented it. I've never seen it implemented so far. OK, so to conclude, as you can see, targeting this system requires some knowledge, but technically, it's OK, right? So the tools that I have used during this presentation are now available on Orange Cyber Defense's GitHub page. Of course, I'm French, so the name is kind of French. So feel free to use these tools, only to make the world a better place, of course. And feel free to improve them as well. There are other things that can be done with that, or the attack can be improved, I'm sure. I have mentioned several other leads, things to do during this presentation. There are more. So I will be very happy to talk about it with you after the conference. And yeah, thank you. It's still there.
Hello. Yeah, thank you for the great presentation. I was just curious about to mitigate this issue. Where do you consider, or who is responsible for this? Is the manufacturers? Is there something they can do, or is it more of an implementation customer?
Well, the manufacturers need to provide this still because it's standard, and at least for compatibility. And there are older material relying on this. So since this is a standard, I don't think this is the manufacturer's problem, but more of an implementation problem, because more recent devices tend to implement the secure version.
Okay, thanks.
You're welcome.
Yes, thank you for a great presentation. I was wondering a bit about the reconnaissance part and the zero configuration stuff you did in the beginning to discover the devices. How noisy is that? Is that something the SOC team would discover?
For the discovery, it's not very noisy because it's multicast. So I think in total it should be, since I'm sending like 4 or 5 requests for each protocol, targeting different types of devices, it's 10, but we can go down to 1 or 2 well, one for each protocol here.
All right, thank you.
So not very noisy, but multicast, I guess it's not very noisy. And I don't often see it in detection rules for network discovery. But I may be wrong, but I've never seen it so far.
Thank you.
Thank you.
talk for Security Fest. I hope you're all having a good time. Now, I'm just going to ask you a quick question before we start. Actually, you know what? Before I do that, let me remind you that after this talk, we're going to have an award ceremony for the CTF and all the other challenges that's been going on. So stick around for that. But now, just a quick query to you guys. What do we think of Russian hacktivists? Yay or nay? Really? Wow. All right, you're going to have a tough time, man. With that in mind, please join me in welcoming to the stage our next speaker, Alex Holden.
All right, I think I need to switch like here. Okay, well, good afternoon, everybody, and I'm here to talk about the bad guys that are a little bit east from here, been conjugating and doing bad things. I'm going to talk about Russian hacktivists, and this is an interesting talk for me because I do a lot of different talks. I talk about different topics, different issues. This is probably the most personal talk that I ever given, the most in-depth, and I'm going to be talking about not AI, which is popular, but really human ingenuity. And as I talk today, I want you to think that the direction that we took with this research can be done by anybody here in this room. And this is also a call for ingenuity actions. We may call ourselves hackers or cybersecurity professionals or anything else. We are here to do something good, do something fun. And this is what we did for a good cause. So this is a personal story. It's a good story, has a happy ending. But it's a tough story about a group called Killnet and its leadership. So Killnet is a group that emerged in Russia. Its birthday is November 13th of 2021, where this DDoS service named Killnet just appeared out of blue. It didn't do much interesting things except advertise itself like we're gonna knock down a website that you don't like for a fee, so place an order and things would happen. And as a hacktivist, future hacktivist group, they were not very discriminate. In fact, DDoS service operating in Russia had very unusual first targets. The first targets of the future trademark of Russian hacktivists, Killnet, was actually none other but Russian government sites. First of all, I love to show you that these are logos of Russian government agencies. The designers have no real ingenuity. They just took a chicken, squashed it, and put on a logo across all its agencies. But these were the first targets of Killnet, Russian government agencies. And after attacking them relatively successfully, Killnet just continued getting its rhetoric for several months, bashing anybody they could. But just a day before Russian invasion into Ukraine, Killnet actually changes its tunes. It proclaims its love for Russia and the Russian government, and it supports Russian politics and the Russian agenda ever since. So the day before the Russian invasion, things changed, and pro-Russian rhetorics really made Killnet to be interesting, unusual, and definitely noteworthy. It attacked not only Ukrainians. It attacked anybody who was against Russian government, against way of life in Russia. It attacked us. The interesting thing that you think about back before 2022, an attack of one nation in cyberspace against another would be an international conflict. It would be almost akin of declaration of war. Yet our tolerances for these types of attacks had significantly changed since Russian invasion into Ukraine. Russian government actually liked that being a part of Killnet was akin to serving in the Russian army. It made it okay for Russian citizens to attack any of their enemies abroad, trying to knock them off the internet, trying to steal their data, try to profit from them. They made it normal. And that's the scary part about this particular group. Legitimizing hacktivism was something that Killnet really did, and they attacked one nation after another, not really looking at who the victims are. One important thing about Killnet: they were not comprised only of cyber criminals. Russia is full of cyber criminals, but the difference is very, very unusual. If you think about it, many individuals who lived in Russia were gainfully employed in Sweden, everywhere in Europe, in the United States, everywhere around the world. Russian IT professionals were able to find a remote job. And that was normal. Nothing was wrong with it. But with Russian invasion into Ukraine, many companies made sometimes difficult decision to fire every single employee who lived in Russia and help them remotely. This was unusual, unprecedented, and big. Now, think about the individuals in Russia, IT professionals, remote help desk, many other professions that all of a sudden lost their job. They were not angry at their government who actually invaded another country. They were angry at their employers. They were angry at our side. They were angry at Ukraine because of this, they lost their job. So many of them have joined hacktivist movement. This is a scary notion that attacks were carried out not only from individual hackers, but people who understood technology on different levels. Think about a networking professional who knew how things were built, who knew how manipulate networking protocols to create an availability on the network level. Or think about developers who understood the application stack and data processing in order to build very expensive SQL queries in order to exhaust remote system resources. These were the directions of individuals who actually joined Killnet. My favorite character of Killnet is somebody's grandma. Some guy wrote in Killnet Telegram channel that his grandma also joined Killnet. He wrote about this, that his grandma sat at the computer for 1 hour every day, opened the Telegram channel, took a site from the list that they were attacking, opened it in her Internet Explorer, and hit the reload button as quickly as possible. Evil grandma. And while grandma could be stopped with arthritis, I don't think a lot of threat actors had. A lot of these individuals still had keys to their previous employers. They had possible access, old accounts, know how to harm their the people that or individuals that Killnet tried to target. This is a new era of hacktivism, and Killnet actually built its case of becoming great in their own mind. Killnet sold merchandise, T-shirts, hats, stickers, rings. The Killnet was a brand name within Russia because individuals were so happy to participate in this direction. Killnet, in its rank, counted over 100,000 individuals who logged in every day, and up over 10,000 individuals almost every day reported participating in Killnet activities in DDoS or other types of attacks against its targets. This is, as a Ukrainian newspaper put, a herd of wild animals who attacked any target on their list. I want to also to introduce you to the leader of Killnet, the guy called Killmilk. But Killmilk is also known as Nikolai Nikolaevich Serafimov. That's his real name, and this is what this guy looks like. He looks normal. He looks like a normal person. If you listen to his family and friends, he is a good husband. And he also fashions himself as a patriot of Russia. He served in the Russian army. He posted these pictures on his social media profiles in the past. But to me, Killmilk was Killnet's leader or cheerleader. This is a person who built propaganda machine to significant amount that it was actually greatly recognized across the world. It was feared, it was revered by others, and it did a lot of harm. This individual is not a good person. He is a racist and a fascist based on his statements in social media and the statements that he made later on to his family and friends. He is also an avid drug user. Not only a user that in 2012 wrote in his social media that his mood is being controlled by amount of and types of illegal drugs in his system, but also a person who distributed illegal drugs. In fact, in 2017, he gets arrested by Russian government for drug trafficking, and he is facing up to 8 years in prison. With minimum term of 4 based on Russian government standards. For some reason, he only serves 1 year in Gulag, because we, in 2018, already seeing his payments and receipts going through normal channels, and he's no longer spending money in Gulag, he's living normal life. This is extremely unusual because the Russian government system for drug users is extremely strict. And getting out with 1 year sentence instead of minimum 4 is unusual. And this is where we think that his cooperation with Russian government began. In fact, judge in his case notes that Serafimov had unprecedented amount of cooperation between himself and the law enforcement. This gave him connections to the government, and the person as a person, he was very charismatic. He used to be a musician in his younger years, but he was not that old to begin with. At the beginning of Killnet, he was only 29 years old. Yet a person like this made the number of social media posts and used his charisma to spew hate, spew propaganda across many different channels. He wrote more than 1,000 posts within Killnet, calling for different types of attacks. He also posted things like this, attacking executives of companies like Lockheed Martin and Boeing. He photoshopped them in the casket for the company's support of Ukraine during this hard time. And in his messaging, he was telling them that this is going to be them if their companies won't stop supporting Ukraine. In fact, 100,000 individuals of Killnet were directed to target employees of Lockheed Martin in a way to get inside of one of their systems. And think about 100,000 hackers incented to break in. They had some success. The most vile posting, the most vile information that is shown in this particular post, original on the left, translated in English on the right, was from January of 2023, when Killmilk posted a short video with messaging asking to attack hospitals. He asked to attack hospitals in the United States, Portugal, Spain, Germany, Poland, Finland, Norway, Netherlands, Great Britain. He called to attack the weak. DDoS attacks or not, his message was to start destroying the medical system. the most disturbing component is a postscriptum in this message. Kill them first. This is the enemy. This is a person who directed others to do harm. And while large medical systems did not succumb to DDoS, there have been reports that some smaller hospitals had bandwidth issues on their emergency communication, on their data delivery, and getting critical information about medical or to help patients. Now, with this enemy in sight, what he didn't know that the days of KillNet were already over. And I'm going to start my story by telling how we targeted this group quite successfully and contributed greatly to their demise. I'm going to start with introductions, and I think this is the latest introduction I've done in the talk. So, hi, my name is Alex. I want to tell you a little bit about my background and why I'm talking about this group today. I was born in Kiev, Ukraine, many, many years. In 1989, my family moved from former Soviet Union to United States. I lived for the last 37 years in the city of Milwaukee, which is about 100 kilometers north from Chicago. And there I became a cybersecurity professional. I've done a lot of interesting things in cybersecurity, and most of my career has been spent on monitoring the bad guys, the cyber threat actors. I've done a lot of fun things, great things. I was saying some people would think it's bad, but I'm proud of one thing on my resume more than others. I've been making Mr. Putin mad since 2014. On August 6, on 2014, my company published our research of one of the largest breaches of that time, probably still one of the largest today, 1.2 billion stolen credentials from 420,000 websites that a Russian gang from Barnaul had gathered. And for some reason, Mr. Putin got very upset. So he put me on his naughty list. But when you get put on his naughty list, you don't get like something in the mail saying, hey, you know, I don't like you anymore, something like that. You don't get a plaque or anything. I get a call from US government the very next day, and they say, this is Alex Holden. I'm like, yes, this is an agent so-and-so from DHS, which is US Homeland Security, Department of Homeland Security. And they just says, well, sir, I suggest for you not to go to Russia. So I told him that I didn't have tickets to go to Russia. I was not from Russia. I was not interested in going to Russia. He's like, very good, don't go to Russia. I'm like, can I ask why? No. Well, how do I? He's like, just don't go to Russia. Okay, fine. Just in case, so it's a reciprocal, I put my own sanctions against Putin. He's not allowed in my house. He can walk down the driveway, he can wait in the garage. I got lots of Ukrainian friends who would love to meet him in the garage and play bad cop and bad cop. But I've been very proud to be able to identify a lot of cybercriminal activity within within Russia and make this guy's life a little bit more difficult, because he's been making our lives much, much more difficult. But let's go back to KillNet. And KillNet been actually this huge movement in Russia. In October of 2022, Killmilk actually doing interviews to Russian media, to this particular edition of RT, which is a Russian television, Russian state media group. He'd done a very, very long interview, which I read because I read a lot of crap coming out from Russia. But this particular thing actually interests me quite a bit. To a question if he has any support abroad, outside of Russia, Killmilk says something very, very interesting that was the beginning of his demise. He actually thanks a group called Solaris for its support of KillNet. And he actually says that if there was no Solaris, there would be no KillNet. So, okay, that's kind of cool. So if we get rid of Solaris, we can get rid of Killnet. That's kind of what he's saying. And I know Solaris, because to stop 100,000 people is difficult. To stop Solaris, it's quite possible. So what is Solaris? Who is Solaris? Solaris was established in 2017 by a guy named Zanzi, and it's a legal drug marketplace back in Russia. It was one of the biggest marketplaces at the time, as it was, I believe, #2 among much of competition for illegal drug marketplaces there. But it operated over 1,000 shops across many cities in Russia selling illegal drugs. It's a complex system. It's very large and proliferated, and I knew quite a bit about Solaris. The reason for it, and the reason why we decided to target Solaris, we actually have been monitoring Solaris for quite a while. So why would a cyber threat intelligence group like my company, Hold Security, would be actually interested in illegal drugs in Russia? And I can tell you one interesting thing I learned many, many years ago. A lot of Russian hackers love drugs, and they buy drugs near their home. So in order to triangulate some of them, we actually been monitoring illegal drug marketplaces in Russia to be able to figure out where these guys live. Because on the dark web, they would use same nicknames, they would use same Bitcoin wallet addresses, and we can actually figure out what's what and where they are. And they buy drugs near their home. So we can triangulate to a kilometer, square kilometer where they live, which is cool. So we've been monitoring Solaris since a year after it started. Zanzi came on the dark web asking about tech support because he had some problems with PHP on his server. And one of our alter egos actually on the dark web suggested for him to talk to our other alter ego about getting solid technical advice. So Zanzi came to our Shadow IT service, and he started asking questions like, can you help us? And like, who the heck are you? Like, who gave you this information? How do you know that you can talk to us? So he was actually proving to us that he is worthy, he is a really bad guy and stuff like that. He forgot to ask us about our credentials, which is good. We didn't have much. But ultimately, he actually gives us access to one of his servers, and he actually asked for help. So it was a PHP queuing issue that he couldn't resolve. So we said, okay, of course we will help. Let's take a look. Got root access to the system. Asked him if we could do backups before we make drastic changes. He said, yes, of course. So we made a backup of the system. Then said, okay, well, if we make big changes to drivers and stuff like that, we can lock ourselves out. Can we get a way to get back in if we get locked out? He's like, yes. So we installed the backdoor on his system. He said that we could. It's legal. So yes, we actually had access to his system since 2018. When he installed Tor node on that system, it became much easier to communicate because he could not see himself what's going on. But ultimately, we had access to his system. And unfortunately, we couldn't figure out the queuing issue that he had because we didn't look. But we can't enable him, but we got access, and he basically he taunted even to other people on the dark web that Solaris is extremely secure. Nobody can get inside of Solaris unless you have a backdoor, and we kind of monitored only to get information that we needed. But Solaris infrastructure was seriously complex. And if I'm going to be talking only from technology perspective, it was really cool because they created a special ecosphere for bitcoins. And bitcoins were illegal in Russia at the time. So he took credit cards or debit cards that they had in Russia and created a conversion gateway that really helped us to figure out who is the real owner of the card, but also created a gateway to convert money to bitcoins, to keep the bitcoins in a special ecosphere for exchanges and make all transactions in bitcoin. So the dealers, the handlers all got cryptocurrency. Individuals just put in their cards and they got everything worked. On the financial side, technology-wise, it had a forum, it had different shops, operating in their own containers. So the system was very, very cool, and according to him, extremely, extremely secure. So we learned about connection of Solaris and Killnet, and we are trying to figure out what we can do, because we have access to one server and they have dozens of servers. And we understand that Killmilk used to have a drug problem, but now he has friends still in the drug business, so maybe this is not a coincidence. So we need to figure out how we can get inside that very, very secure system that nobody can get into, having access to one server. Well, thankfully, Solaris staff also saw that everything is extremely simple, and to most of the servers we can get through SSH keys, because they left authorization keys there on that server. So we were able to move among the infrastructure, but we could not get to really interesting servers that actually had forums, chat logs, and some of their source code. So that's where we actually noticed that we have access to Ansible server. So Ansible server, we're able to run some jobs and get ourselves access to other systems. But we still couldn't get to the Bitcoin exchange because it was extremely secure. So we got access to the Zabbix server, and Zabbix server was doing a great job monitoring, but we ran a couple updates, and now it was not only monitoring, but giving us access to the entire infrastructure. So bit by bit, we were able to gain access and control almost every single aspect of that infrastructure. And we were ready. We were ready to do something really, really cool. This was a plan that we conceived to topple Killnet, not to go after Solaris, even though it was a really cool thing to do as well. But we remember that back when, Zanzi asked us to fix a queuing issue. So we decided to fix a queuing issue. Not exactly with PHP, but every single day, at the end of the day, they would do reconciliation, and they would transfer all the Bitcoins in their ecosphere to their own accounts. So we put a different Bitcoin address in that, and by that we led them to adjust their own queuing system, and we did something really nice. We got the Solaris drug lords to transfer 1.5 Bitcoins to an account of a Ukrainian charity. They did everything themselves. We just adjusted the queue. We were asked to adjust the queue 4 years before. I'm very happy to say that we were able to assist to this charity that helped elderly in winter time during the war. And this great charity actually gave every single cent to those who needed. 1.5 Bitcoins were significantly less than. At the time, it was only 25,000 US dollars. But when the charity actually put this, cashed it out, it was over 40,000 euros that they helped. And definitely this was great. Forbes magazine wrote a story about this. And this was part of our strategy. We went to Forbes not to tell about particular situation of transferring money to charity, but also to highlight connection between Solaris and Killnet, to say that there is a connection. Well, Solaris reads the story and they issue this particular statement. Highlights of the statement. First of all, they're saying that nobody hacked us. Look, we are still up, so no breach. Then they said that don't read everything on the internet. They lie. Can't argue with that one. And they say, well, don't panic. Everything is okay. Your money is safe. Don't manipulate. You're being manipulated by our enemies. So they reassured, but just in case, they're going to take down the system and make everything more secure. So they take the system down for several days. They make everything secure. They come back and say, this is the most secure, never been breached system ever, because there was no breach in the first place. And now it's all secure. So we see that they secured everything, and they're doing great. So we can log into their very secure GitLab server to take a look what they changed, because they fixed everything. So what they did, really, they changed the Tor address, obviously. They also changed the copyright date. They adjusted logo a little bit, and they changed the message. Not a huge improvement, but very, very secure. So 3 weeks later, we go on our own to play off the Forbes story and publish a story on our site. And we publish a story with a goal to connect Killnet and Solaris. We also not doing only words, but we are dumping all information from Solaris into public eye. We disclose information about their DDoS guards, configurations and access monitoring framework, their catalog, their source code, their forums, their exchange information. Everything about Solaris was made public. And Solaris didn't fare well. First of all, Kraken, which was #1 illegal drug marketplace, definitely took advantage of this. They took over Solaris infrastructure, and at least for a short while, they routed traffic to themselves. Zanzi decided he was done. He left the project and continued living in Moscow under very assumed identity. And Solaris itself started fading to obscurity. Well, they said that they fixed everything. A month and a half later, we log in, just check if they fixed everything. They did some improvements. They got much more secure, but didn't kick us out for some reason. But the underlying part of the story, Solaris' final demise, took us longer than expected, but in 2024, Solaris finally calls it quits. It closes remaining 100 shops, which was a very small amount after 1,000+ shops running at its height. But it blames everything, everyone, and it goes away. So Solaris became irrelevant very shortly after. But we had to also weather the storm. We went public. We were using a company name. I was using my name to get this story across. I don't do this very often, and there is very little logic to this. But there is a big difference. This was something that had to be real. It had to be big. It could not come from anonymous source on the dark web. It had to be significant enough so people would pay attention. I'm wearing a T-shirt made in Ukraine. And being born in Ukraine, I understand and sympathize my fellow countrymen who are risking their lives every day by just living in that country. If my family didn't take myself and my brother out of Ukraine in 1989, we would have been serving in Ukrainian military. And my life would not be endangered much by doing what we did. But if I was in Ukraine and most Ukrainians risking their lives much more significantly than I ever did by doing this. So, but there was still a huge amount of cyber threats on the internet. There was a doxing attempt against me directly. I'm not even going to translate what's written in that posting from Kill Milk. Also swatting, and there were several swatting attempts against myself and my family. Thankfully, having good relationship with our local police department, all these attempts were handled highly professional by them, and no lives were endangered at all. So this is also good. And as I said, small amount to pay. Compared to many others who pay much differently. But this had worked. This worked on a grand scale because somebody in the Russian government noticed this connection between KillNet, KillMilk, and Solaris. And they felt that the group that they were supporting, the Russian hacktivist group that they built up, was actually up to no good. They paid attention enough that in February of 2023, Russian government pulled all its financial support from KillNet. They still managed it a little bit remotely by taking the resources and the results of their scans and attacks. But Russian government had actually stopped supporting KillNet actively. And Russian government had not tried to do this massive scale project ever again. KillMilk goes broke. In filings, in financial filings, KillMilk actually tries to pawn 4 of his cars. He and his wife own 4 cars. And he bought all of them between 2021 and 2023. And in February of 2023, he actually tries to pawn and take all money from under these cars because he is going broke. He's taking other loans from different sources in Russia. His wife is taking microloans to pay for her nails and hair. I know that somehow. But we see him struggling, and we see him actually trying to do different things without clear direction, without being handled by professionals. He makes a statement at one point in social media saying that KillNet is no longer free and doing this for great cause. We are now for-profit outfit. And the 100,000 followers said, yeah, it's great, we're going to get paid. And he's like, no, just me. Like, okay, that didn't work. So try number 2. He decided to disband KillNet. He posted a statement saying that he lost trust in the KillNet collective. Everybody is fired. He will reassemble it completely. People start leaving the channel. He's like, no, where are you going? And we're just rebranding and stuff like that. So that he just lost a couple of hours. Then he finds that he makes a statement at some point that he is handing over KillNet, the entire channel via KillNet in Telegram and all the assets to another threat actor named Darkside. And then somebody else on in Telegram channel said, well, did you used to call yourself Darkside about 2-3 years ago? Or he's like, oh, yeah, it didn't work. So he's like coming up with all these schemes and screws them up completely and then like, okay, we'll start over. On October 6th of 2023, KillMilk actually makes a post that made sense. He makes a post to his followers asking them to follow the Red Cross guidelines, meaning don't attack civilian targets. Don't attack anything that may actually harm civilians, even if it's a military target. It was an interesting and a great step where it actually made sense. I understand the war, but stop harming innocent civilians. Stop targeting foreign targets. October 6th of 2023 was a nice day because the next day when Hamas attacked Israel, KillMilk changes his tune. throwing his support behind Hamas, condemning Israel, and looking to make more powers from that tragedy. He actually looked and called for more attacks, disregarding and deleting the previous post about peace. So that's kind of how it works. And then in the beginning of 2024, in the first days, Killmilk actually sells via Killnet channel to a group called the Anand Club. So for less than 10,000 euros, Killmilk actually sells his greatest achievement and starts doing something else. It really, like, I couldn't believe what the Anand Club did was the via Killnet channel. So the channel that hosted more than 100,000 followers, 129,000 to be specific at its height, only had 3,000 members. And the Anand Club turned this channel into a channel that actually hunted and identified Russian illegal drug dealers. I don't know where they got the idea, but kind of like, but I can tell you why this happened. Whoever ran the Anand Club was trying to rebuild Killnet. And the biggest hurdle that it had was the Russian government, that its connection to illegal drug trade. So the Anand Club decided to do something different and try to draw that differentiation. They actually have done quite a bit of demonization, but not much happened besides hurting a couple drug lords. Killmilk himself was doxxed, identified as Serafimov by Russian media. So the people who actually worshipped him actually turned against him. And he tried to fade to obscurity. He becomes irrelevant. Last year, he posted something, or he incinerates a hoax where he posts that, or somebody posted that Killmilk was killed. Nobody pays attention. He comes back 3 days later, says, "Oh, I was not really killed." Nobody pays attention. He gets so desperate, he actually starts releasing music. So he released profanity-ridden album, two tracks. They're not fun. He can sing better than I do. That's maybe one interesting thing. But he became completely irrelevant, and nobody really pays attention to him. He sells now courses on how to use the dark web. Don't buy it. They don't have good reviews. People who bought said that he was just Googling things or finding things on Yandex and sending that to them. But this is a story about winning. I'm not going to take full credit for taking down Killnet. Many different factors came to it. This was an interesting direction about a small group of people, myself and 8 my other colleagues living in Ukraine. We took this project out of our company and decided to accomplish something. We found the Achilles heel that actually killed the giant. We couldn't come up with a better plan, even though it was executed over a serious amount of time. It didn't happen immediately. But it still worked to wound this group. And the biggest thing is that the Russian government didn't try to do this again. So we were able to stop them. And this is a story about making a difference. Whether it's something great like this, because it does feel good when the plans comes together and the bad guys close their shop. But also making small steps. It definitely helps. We do a lot of fun projects. And when you imagine a project in cybersecurity where you can make a difference, I encourage you to try. And this is why I'm standing here telling you a great story that have a very good ending. Thank you very much for your attention.
Alex. Thank you, Alex. Really nice talk. Thank you. Surely there must be some questions. Hands in the air.
Do you see anyone?
I can't see anyone. I'm blind, though. No one. Okay.
All right. Well, grab Alex afterwards. Oh, there's
Yeah.
one.
Oh, we have one. Sorry.
Yeah, you mentioned 100,000 supporters on Killnet, one grandma, and then you also mentioned that the Russian government pulled the funds. Did you see any change in their motivation, and do you know anything more about the motivation of these 100,000 people? Is it love for Russia? Is it monetary?
So there was no monetary incentive there. The other APTs coming from Russia that have employees, people who actually get paid. Killnet was never meant to be paid for profit group. When the Russian government started this project, and we feel that there was this issue with attack against the Russian government in the beginning of Killnet's existence, and the Russian government came back and they looked who did this, and they changed the group dynamic by force. And they decided to do this project, Killnet, that became a hacktivist group. The hacktivist group was actually fueled by IT professionals, by normal folks who didn't like the drama, but they did like to be part of a collective. So, if you read the Russian media at the time, it was the place to be. That's where that 100,000 came. And the height I'm also attributing to a lot of onlookers, including ourselves, watching the channel. So, but these individuals were not really incentivized financially. They were calling themselves patriots. It was a cool thing to do. Some people were really hurt by the war financially because of losing job. There was great animosity against the West, more so than against Ukraine, because we were meddling, in their opinion, in Russia-Ukraine business. So that was the driving force, and Russian government was handling this. They were directing, and the Killnet elite, which were about 100 individuals, were definitely connected to Russian government directly and indirectly. They the ones who directed the attacks. The rest were just followers, and the followers movement didn't work. The APT stuff did.
Sweet.
Anyone else?
No one is moving. It's still freezing. No one else?
Tired.
Yes, there we have one. Good. The energy is a lot lower in the room. Everyone is just like, please God, let it be over. Power through, people.
Yes, thank you for a good presentation. Cybersecurity is one thing, but do you fear for your own safety when you sort of poking at Putin and making him upset?
There is a threat, but as I said, people in Ukraine risk their lives much more. I don't go to Russia. I was told not to, but the idea of being careful definitely applies. I feel safe here in Europe, in the United States. I don't go to other places that have questionable connections with Russia. I think I contribute enough to feel comfortable, but I don't do stupid things, and I'm relatively careful with my footprint on the internet. So that's something that comes natural for many years.
Thank you.
Okay.
All right. Anything else? Do we have time for one more? If there is one more, otherwise you can grab Alex afterwards, I'm sure.
Yep. Let's do that.
All right. Thank you so much.
Alex.
Thank you.
Kör upp lite grejer då. Okay, but now we have we're gonna do like a brief prize thing or awards thing.
But you're supposed to be up here and I should be there.
Yeah, not really though, because the first one is Splunk.
Oh yeah,
and
that's right.
Cisco.
You guys should be up here.
You guys should be up here. Come over
You
here.
the guys from Splunk?
Yep, they're here.
Splunk.
Get up on stage. Come on. Come on. Come on.
Ooh, we need a mic for you.
You need a mic.
1 second.
One microphone will arrive. So this is the prize for the sim racers in the room. Are you here? Did anyone try the sim race? I bet they are. Hopefully. There you have a microphone.
There you go.
Take it away.
Thanks. So I'm from Splunk, and we had about 10% of you visiting our booth, trying the Silverstone circuit, and you were doing great. And you know Splunk is the best T-shirt company, right? There was one guy, he actually tried 4 times, didn't make it. The third runner-up was Satya. That was his first time driving. He did it in 1:30.846, 1 minute 30. That was really good. That's the first time. Usually people end up in run 1:40 to 1:44. So he was good. Then we had Stortonfisk.
Anyone here by that name?
No one. 1:30.447. And the winner was on 1:30.373. Robin, in his second attempt.
Robin?
Robin?
We got a Robin? Hey!
When you speed as you do, you need some glasses, right? And then when you've been speeding around the Silverstone, you get hungry. So here's $1,000 for McDonald's. Cheers.
Hey! Not bad. I'm gonna need that after this.
Thank you. Okay. What should we do? Should we do the satellite prize?
Yeah, I mean, let's just run through them, guys. You won award, right?
So,
I'll be here getting the stuff for you.
Assured actually had a bunch of satellite challenges, and I think the prize was basically for the one who sold the most of them, not fastest or something like that. So, with that being said, do we have the badgers in the room?
Are there any badgers in here at all?
Yay! Nice. Do you want to do the handover? You want to do the handover? Yeah, you should.
You can.
You should. It's there, it's there, it's there.
Which one? This one? Oh.
Where is it?
Didn't you put it on stage? No.
No, I didn't think I brought it.
Is it here? No, it's here.
Surprise.
Okay. You grab it.
Okay. So here
we are so
is
organized.
your prize. Awesome.
Hey! I really wanted one of those. That looked
awesome.
Cool. Yeah, me and Jesper were looking into getting some prices, but Lego was just way too expensive for Security Fest.
This is on, right? Yep, go ahead.
So he had 5 solves, and second place was Meh, who had 4 solves, actually more points. But what we wrote in the price description was that most solves was the criteria. So maybe it could have been a bit unfair, but congratulations.
Thank you. Hey!
Okay. Everyone is dying with suspense. How many in here did participate in the CTF?
Oh, there's like 4 of you.
4 of you. Was it fun? Yeah. Everyone said, yeah. Yeah, it was really fun. But, as all good competitions, there could be only one. And, who was it?
I don't know. You got the telephone.
I actually got this. I actually got it. So Lee is actually the winners.
Come on, are they here?
Are they here?
Yeah. Come on, boys.
Woohoo!
What do they win, Jesper?
Sorry?
What do they win?
They win a bunch of power banks and some cool lights.
Right, we couldn't afford Lego,
And
guys.
they win some home automation stuff. Thank you very much for participating and winning.
Yeah, good job, guys.
Sorry? What? Yep, go ahead. It's on.
Turn it on.
Just
It's
go.
on.
But I don't think I need it. I have the strong voice I usually use.
Do it.
So they didn't just win the prize, like they didn't just got most points. They saying fairly, they actually found a very big issue in our CTF. Instead of exploiting it to get even more points and obliterating everybody else, they reported it to us, did a very responsible disclosure, and instead of destroying the fun for everybody else, decided to play with real sportsmanship. So they don't just want the first prize, they actually were the most sportsmanlike thing that they had participated in.
Hey!
Then you get chocolate!
Now, isn't that just a Kodak moment?
It is a Kodak moment. Thank you
right.
guys. But
Thank
there is also actually not only a winner, there is a second place as well.
All right.
Hopefully.
Usually we start with the second place, but you know, all right.
No, but it's more fun. Like the cool, everyone wants to see the cool stuff.
Okay, all right.
Now it's it's Sectra, I guess. Are they here or did they leave?
Sectra? Yes. Come on up here.
Yay! Oh, you too many guys.
Oh, there's so many of you.
The
we
prizes
don't have
are
enough
dropping.
power banks. Sorry.
Pick a game, any game, not that
Thankfully,
one.
we have lots of board games.
Good choice.
All right, we had one board game.
I just want to say, you're second, and you're 4 times the amount of people.
Yeah.
You should be ashamed. No, I'm just kidding. Thank you guys. You can leave now.
Way better than what I did.
Yeah. Yeah, I didn't. Yeah.
Exactly.
Okay.
All right.
What else?
What else?
We have this thing called the Swedish Hacker Award thing.
Yeah, we premiered it this year.
And it was an amazing success, guys.
It was.
Insanely.
You would not believe it.
2 submissions.
2 fantastic submissions, which is actually great because I think, yes, but we have 2 prizes, right?
We have prizes to them.
Yeah, and I think we bought 2 of them. So that's...
Do you want to read it, and I'll sort of do
Should
it?
I read it?
Yeah, you should read
All
it.
right.
It's the...
Oh, wait.
Yeah, we rehearsed this in the...
That's your wife. No, hang on.
That's sort of the same
Oh, all right. Let me do this from the top, right? The Sweden... No, wait, hang on. The first ever Sweden Hacker Awards. Didn't we already say that? Great success? 2 submissions? Yeah, all right. Hang on. I'm going to scroll. All right. For an interesting text closely describing the feeling, progress, and failures from one of our sponsors' CTF challenges. That's what we're aiming for. We start with our first story. Do you guys know SCP, Secure, Contain, Protect? Yeah, some people do, right? This one's called SCP-7842, the Flag, the Witch, and the Regards. Please, can we get Peter Tvingmark on stage?
Peter! Woohoo!
Come on.
Tell us the story, noble sir.
Can everybody hear me okay?
Yes.
Nice. So I want to tell this small, short novel about the KITS CTF SCP anomaly. So, first things first. Special containment procedures. This write-up is to be stored in a secure location, far away from anyone who actually knows how to use GPG. Anyone who reads this are to be initiated, not because of its content, but because of second-hand embarrassment. So, phase 1, the login. We sat down at the CTF at KITS challenge terminal. The CTR monitor gave us flashbacks because anyone who's old enough knows that you can cook a Billy's pan pizza on top of one.
True story.
Yep. There was also a walkie-talkie radio and a landline phone. Very good vibes for his CTF challenge. So, first order of business. We logged in as Morgan, credentials that were supplied to us. We started reading through the messages left on the system, and the transmissions painted a picture of the Foundation operations gone totally sideways. Most of the messages were atmospheric world building, but one message stood out. It was an offer that couldn't find a number. So we did what anyone could do: find the manual, find the number, and the number was 1-800-HILFE. Hilfe, for those who don't know, is German for help, and we were very much going to need it. So we picked up the landline, dialed the number, and a recorded female voice answered, professionally and calm. The kind of voice that reads you your SAP containment briefing before all the lights go out. And she said, if any other voice talks after mine, ignore it. And this was very creepy to hear. It gave me actual goosebumps. You know the kind of chill that you get when you feel that someone is behind you, and you look back, and there's no one there? Very creepy. But the message continued. The landline was compromised, which is kind of obvious because you just told us that a ghost might chime in at any time. And we were instructed to switch to the AM band frequency, and that the message would be encoded. So we hang up the phone, start the radio, and turn on to the instructed frequency. And we started listening. First, it was only white noise, and then came a voice, 87, 76, 69. And many of you know the mapping of the numbers, and we started immediately, those are ASCII numbers. So we grabbed the reference, started mapping numbers to characters, and decoded the transmission into a word. Finally, a passphrase, and we thought this could be the key to the kingdom. So we had everything, an encrypted file, flag.gpg. We had a passphrase, we had everything we needed. What could possibly go wrong at this time in a CTF? And let me tell you, everything went wrong. We entered it, and GPG did nothing. We typed GPG, flag.gpg, and entered the passphrase. What more could you do? We got no output, no flag, no nothing. Just a cold, silent terminal staring back at us, just like SCP-173 is waiting for us to blink. We tried again, same result. We tried variations, we decoded the message again. The clock was ticking. We had multiple people behind us, staring us down. Our lack of confidence were all at the same time eating up our dignity as well. Time ran out, we walked away, defeated. Just a handwritten note in our pocket that said, jittery data. Next team sat down at the station after us, fresh eyes, fresh terminal, and on that terminal, a little file. A file we had unknowingly created because, apparently, gpg.flaggpg, without the decrypt flag, writes the decrypted message to a file. So that's right, we already had decrypted the flag. GPG just wrote a file instead of writing it to us, and we were too busy panicking to notice. So this absolute legend competitor waltzed up behind us, and as all do, ran ls in the terminal, noticing this suspicious file that wasn't supposed to be there in the challenge. He opened it, and there it was, the flag. Our flag! The flag we had working hard for, and the flag we had decoded. So a couple of hours later, we were back at the scene, and me and my colleague talked about our progress, and then it hit us. If we only had read the manual with GPG, we knew, and we found out that you need to use the decrypt flag. It was right there. It was always right there. The one flag we needed to capture was the one flag we forgot to type. And we did solve the entire puzzle. We read the lore, did a login, called the landline, listened to the radio, decoded the ASCII message, typed the passphrase, and fumbled on the literal last part of a CLI command. Armed with this devastating knowledge, we marched back to the terminal, ready to finally decrypt our way to glory. So we sat down, cracked the knuckles, and typed down gpg-decrypt flag.gpg, with the confidence only known to a back-to-back champion MMA fighter. And we entered the passphrase, incorrect passphrase. I'm sorry, what? We had everything correct. But turns out the challenge had rotated passwords between sessions. So once again, we speed ran the entire challenge from scratch. Call 1-800-HILFE, get creeped out again, slightly less. Grab the radio, tune on the frequency, and decoded the new ASCII transmission, and extracted the new passphrase. And there it was, finally, the flag and limited t-shirts.
Woo! And
I think that definitely deserves a prize.
This fancy plaque.
The first annual Hacker Awards.
The first
winner. Woohoo! How cool is that? That's awesome. That's great.
You get this as well.
Keep
it in.
Oh, what's? Oh yeah. Oh, fancy.
But I think you should have a board game as well.
Yeah, grab a board game.
You should have a board game.
We've got like 3 of them. So.
Uh-oh, this is trouble. We forgot something. No, we didn't.
No.
It
He's
was
just
only
taking
photos.
pictures. It's fine. Thank you so much. This is why I don't do CTFs anymore, because you have to read the fucking manual.
But we do have one more.
We do, but your phone is locked, so I can't read it.
Well, then it's locked.
Well, you do it. I'll do this
I'll do
part.
it. Yeah.
This part looked way
No worries.
easier.
Okay, so that was one. And then now I know what you mean. You don't, but you need to scroll. Next up, our second contestant and winner, obviously, because there were two, which is fun and all. By a special crafted GraphQL query, he got lucky in every stage. They were the first to finish this GraphQL challenge in the CTF, and now they will demo their solution for all of us to see. Welcome, Albin, on stage. Albin, are you here?
I think that's him.
There he is! Nice. Let's hope everything works. It's the last. Nice password. Here you go. No. It was very easy. It was password 1. See if it works. There you go. Okay.
All right. So, this is... Oh, I can start like this. My name is Albin Suljov. I'm a security specialist at NLISEG in Linköping. I'm, for the most part, do penetration testing, but enough of me. So this is just how I first blooded the last GraphQL challenge, with just basically one tool, one extension. And for some reason, I was the first one. I'm quite happy to be the first one. Also, apparently I did the two previous ones. I'm a sucker for speed. I don't know if anyone likes to do the CTFs on Hack the Box, but there's the same thing. If you first blood something, you're the first one in the world to make it. But let's see if I can do this at the same time I'm hacking. So I didn't do anything fancy, anything frameworks. Just straight up one tool, recon, and common knowledge. So we just have the simple web page, no buttons. And if you look at the description, it's just GraphQL. Okay, fine. I just need to find the endpoint for this. So, oh, wait. All right. All right, it's shut. But it shouldn't. Wait. Yeah. Funny when it's a disconnect from my computer and all that. Let's see. Can't prepare for everything. All right, let's go. It's fine. I just can do it fast. If it's want to load for me. All right. Basically been hacked, yeah. What? Yeah, exactly.
Yeah, it never works out.
While it's loading, I did a demo about MFA hacking on Azure, and basically, I can bypass the MFA. Didn't work because the web browser cached everything, and I just needed to redo everything. Okay, let's see. What? All right, well, I can do basically like this. Just skip a step. I walk into the endpoint, I see it, and when I just burp suit to proxy it, And just I can see right here how the request looks like, and the answer just here is on parsable JSON body, just to find it. And after that, we just basically need to find the information schema and the introspect of the GraphQL. Basically just what the request needs to look like, if there's any parameters and all that. And we have this extension, GraphQL Scanner, which automates this workflow for me. Basically makes it way faster than need to take this 200 lines payload to make it work for me. And it's just simply the URL with the GraphQL endpoint to it and basically the request template for it. And in the end, you're going to get something like this. You can see the queries. We have fetch telemetry and hello. Since there's talk about telemetry in the description, this is the first thing I'm going to look for. So I just put it in repeater, and I can just start hammering at it. And the parameters is URL. It fetches external or maybe internal endpoints. So this is where we're going to start. We try 127.0.0.1, didn't work. HTTP, localhost. It works. And we try HTTPS, it kind of works, but it gives me, it doesn't exist. We also, but then we're going to check, I need to brute force every single port just to make sure, is there something exposed internally? And of course, we can try the most common ports. If 443 doesn't work, if port 80 doesn't work, is there any fun port we want to try? I just simply guessed 8080, and it worked. Speed by guessing. So by simply finding, there's something running, I can just simply, and I get, and it just shows me, there's an endpoint you can go to /flag. Just simply find it in the payload, localhost 8080-flag, and it just simply returns the internal server and with the flag. Simple as that. Speed is everything, at least for me. I don't know about you guys, but that's it. Simple hacking, simple points. Thank you so much.
Awesome. Thank you. Now, before you leave the stage, we have this, I wonder what it could be. Some Lego. Well, there you go. Our second winner ever of the Swedish Hacker Awards. Very well done. And you get this nice box with some satin stuff in it. Thank you. All right. Jesper, do we have anything else? Nope. No, that's it? All right. So our next speaker is going to be on in about 10 minutes. Yeah. So, yeah, you know the drill by now. We'll set it up, and then you come back, and then we do our next speaker. Thank you.
Everyone, it's time for the last talk of the con. And here to talk about persistence and how to stay stealthy when you're doing intrusions and whatnot, it's our favorite Alexander.
Yes, thank you. I'm going to talk about persistence, and let's start about like how do we define persistence and what do I mean when I say persistence. So the term persistence is like fairly well documented actually like in meter and stuff like that, but I think the key thing to realize is that we're talking about a threat actor that already have access, like they have domain admin or they have admin or they have root or whatever you want to call it. So don't try to think in terms of like, yeah, but you need to have admin to do that, because that is the scenario here, right? If you think that you're a red team and you compromise a target, you want to keep that access somehow. So saying that you need to be root or you need to be like, in the kernel or whatever to do this, then that doesn't make sense, because that's kind of the point. We want to keep the access level that we're currently having. And the same thing is that like a lot of people might think in terms of like, but this isn't even important because you need to like reinstall the system anyways. Like if someone had root access to your server, you need to reinstall it. You can't trust that server. But unfortunately, it's just not that simple, right? You have these like really big enterprises and they can't just reinstall. So we need to try to clean some systems because they can't reinstall and can't just build a new environment just because they've been breached. So, persistence is a meter thing. Here you see they have like 22 techniques, which is a good start. Meter is a great resource, but obviously, and I think that's kind of the point of this presentation also, to show that there are way more than these 22 tactics or techniques. So we can't really stop at that. And if we go into like some examples, we have, for example, startup apps. That would be like the easiest example ever, maybe. So in Windows, you have these startup apps that if you want to keep persistent access to a system, even if they like restart the system or your malware crashes or whatever, you can register it as a startup app, and then it's going to start by itself, right? It's not exclusive, obviously, to Windows, but you can, for example, do the same in Linux with etc defaults. So there are some scripts that are going to be sourced every now and then, and you can put your own malware in there. Same thing with cloud. You can obviously have persistence in cloud. So if you take like an enterprise app, for example, in Azure, you can register that, or you can even like take out a secret of an existing enterprise app, which is more stealthy than just registering your own. And the same thing, it doesn't really have to be like a malware per se. It can also be like within an application. So for example, a web shell would also be some kind of persistence. So if we try to like wrap up what persistence is, we're talking about the persistence technique, meaning like the scheduled task or the service or the startup app or whatever the technique is. That's not necessarily the same thing as the payload. So for example, like Cobalt Strike is not a persistence. Cobalt Strike is kind of the payload that is being started by a persistence technique, if that makes sense. And we can have persistence in user context. So if you only compromise a specific user on a system, for example, then you can install persistence within that user profile. But you can also have persistence that covers the entire machine if you're like root on the machine. Or it can actually be like persistence over an entire Active Directory domain if you're a domain admin. The way the persistence kicks in or starts or triggers is usually event-based, but it can also be like scheduled. So like a scheduled task is the most obvious example of that. But it can also be manually triggered. So meaning like if you, for example, create a user account on a RDP server, then you need to log in to like trigger that persistence. And same thing with other types of persistence that you need to trigger manually. So it's not only like login persistence we're talking about. Now I'm going to show another example, and bear with me. There's going to be quite a lot of screenshots here, but we're going to get to the point, and I hope you make it all the way with me.
This is from a real incident, a persistence, and we're going to see if this is a good or if it's a bad persistence. So there's this scheduled task called reg idle backup. It's a default scheduled task in Windows. This is the legitimate one. This is what it looks like after the persistence is installed. It's quite hard to see the difference, right? So if you look up that CLS ID, you see that it has this property treat as, which points to another CLS ID, which then has a local server defined, which is this PowerShell command, which in this PowerShell command you have an invoke execution with a base64 encoded thingy, which decodes to another registry path, which contains the next step of this payload, which is in a prog ID, which is this PowerShell function. And by the way, that will also be piped to invoke expression. And that finally, after a bunch of obfuscation layers, ends up in a ms build command line, which points to a file on disk, which is a csproj file, which contains the shellcode that's going to be eventually running the malware. So, is this a good or is it a bad persistence? What would you say? I would say it's a bad persistence. So this is I don't know if it's even cool, but like PowerShell droppers are not really the newest, coolest thing. But I think this is an example of a really, really complex persistence technique that in the threat actor's head felt really, really good. But when you look at it, like, the final payload is still on disk. So like the entire keeping things in the registry is completely doesn't make any sense. And when we talk about the treat as property, for example, it's really bad because it doesn't melt in at all. In my 8 years or something working as a forensic, I've kind of only seen a treat as property once, and this is the case. So if I find that, it's going to stick out really, really much. And in the same way, if you have a big PowerShell command in a registry key, that's not a very usual registry key. So if you can look at all those, you're going to see that this sticks out quite well. So we take another example, if we all agree that that's not a good example. This is actually the most common persistence we see. This is legitimate remote management software. So we talk about AnyDesk, for example, or TeamViewer and this kind of thing. Would you say that that is good or bad persistence? I mean, I think it was a good answer, someone in the crowd. And it depends. It's kind of good, because it's really, really good if it's actually used legitimately. So if there's an organization that uses AnyDesk all over the place legitimately, then it's really, really hard when you look at 1,000 systems to figure out which one is the bad AnyDesk installation, right? And same thing if you have this OT environment where every single vendor installs their own remote management software. And yeah, someone is laughing because that happens all the time, unfortunately. And of course, it's going to be really, really hard if someone jumps in and then installs TeamViewer on one of those servers. It's not going to trigger anything because it's not a malware. It's not going to trigger any antivirus. It's not going to trigger anything. I mean, unless you have a really, really good idea of what software runs in your environment. Plus, the effort compared to the profit is quite good for the threat actor. It's really, really easy to do this. You don't have to maintain some kind of C2 even. You just run well-known software. But of course, if you're if you're NSA, you're probably not going to drop AnyDesk on a server, right? I mean, maybe they are. Who knows? But I think this should be better persistence techniques. So let's look at some examples. But before we do that, let's try to understand how do we work when we try to find persistence, both as detection engineering, but also in terms of incident response. So what are the challenges that we are having, and what are the really, really I used to work as a red teamer, but then I switched to the blue side, and I've been working for a few years with that. And the question is if I would go back to being a red teamer, how would I do persistence? And that is kind of the idea with this presentation, and thinking how can we make persistence better? And if we look at the cases where we have failed, or we have done an investigation after another company and found persistence that they missed, I think the most common case is the investigation scope. So unfortunately, a lot of customers say to us that, like, this is an Azure incident. So you get access to Azure and you're going to do an investigation in Azure. But the threat actor don't really care what's Azure and what's on-prem or what's in AWS and so on. But it's kind of hard for us to say to the customer, oh, but we also need to do investigation on 2,000 servers, even though you only find this one thing in Azure, because it's going to be quite expensive for them, and it's kind of hard for us to get the scope right. And I'm sure we are not the only company that have those challenges, right? So that's a problem, and it kind of comes with the same thing with the time limit, that we have a limited time to try to find all of these things. So, it would be awesome if we could take like a disk image of every single server and do like a proper forensic investigation of every server. But the problem is when the customer has, 500 terabytes of servers, you're not gonna, the company is not gonna exist anymore when you're done with that forensic investigation. So you need to have like these shortcuts to do forensic investigations in a big enterprise. And same thing is that when we do investigations, that things might have happened 2 years ago, but the log retention is depends on what system it is, but like 90 days, something like that. On the DC, it's probably like 5 minutes for the security log. And 2 years back, it's quite difficult to figure out what happened. But when we look at it, we try to look at, if we're only talking about persistence now, in terms of the installation and the dwell and then the activation of the persistence. When we talk about the installation, we get quite a lot of different artifacts. If this is like a Windows service as an example. So we have like prior to the attack, of course, we're going to see that someone is inside the environment and messing around and then installing the service. And when they do install a service, that's going to be logged in several places. You're going to get file records written. You're going to get all these types of things. Then during the dwell time, you have something lying there dormant, which would be like in the registry. You have like in the system hive, for example, you have the service lying there configured and all these things. And then in the activation, when the service runs every now and then, or when the threat actor goes live again, then there's a lot of evidence as well. Then to do this, we have a bunch of tooling. And we have, for example, like sysinternals outruns, and I'm not even going to go through all of this because it's just way too many tools to even go through. Point is that we have a lot of different tooling, and I'm not sure if all of them are great, and it's just way too much work to go through all of this. So let's just ask AI, how do you do this? So I asked GPT 5.5, give me a list of tools and how do you analyze persistence? This is how we're doing investigations these days, right? So it tells me that autoruns is the #1 tool. So let's take a look at autoruns. So here I have autoruns on my domain controller. And if we look at autoruns, it's basically a tool that looks through all different types of startup apps. They call it ASEP, like auto start extension something. And you have things like logon persistence, you have things in Explorer, you have scheduled tasks, services, drivers, and blah, blah, blah. And this is a pretty capable tool. It's not that bad. You run it, you try to find a bunch of things. You have a command line tool as well. This looks all good. Then I start PowerShell on this system, and I pop a calc. So that seems odd. Let's start PowerShell again and see what happened. Popping another calc. OK. That seems like we have persistence on this system, right? So every time an admin starts PowerShell, they're also going to start my malware. In this case, it's just calc. So let's search. Do we have any match for calc? None. Let's also refresh and see that I'm not cheating. And we still don't have any calc. So what super advanced hacking trick do you think I used to bypass this solution that GPT 5.5 said is the best? So I went to Documents. I went to this file. I used this hacking tool called Notepad. And then I wrote calc. Cool, right? So, I mean, this is obviously a really, really simple persistence technique, but the point I'm trying to show here is that these tools are as good as what they're looking for. If they're not made to look for PowerShell profile persistence, then they're not going to find that, right? And it's just kind of the same with every tool. It's not just, not trying to bash on autoruns at all. It's just like, all these tools are going to have their limitations. And there's just like so many persistence techniques that it's going to be really, really hard to do forensics this way. And to be fair with the AI, it actually said, if you read the full answer, it didn't say only autoruns. It said that if you want to have a decent baseline, you should do autoruns, Velociraptor, Cape, Eric Zimmerman tools, Reg Ripper, Sysmon, Chainsaw, Volatility, OS, blah, 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 blah. And then together, they should have a reasonable baseline. And it's like, yeah, thank you. I'm going to run every forensic tool in the world, and then I'm going to have a reasonable baseline. It's very useful as a forensic investigator to do it that way. If we just stick on autoruns for a moment, so another thing which I think is really important to know with autoruns is that the way it presents the data, it shows you kind of the executable. So if you're using like a lol bin or a DLL sideloading, it's also really, really bad at showing those records. And if we move on, we're going to show some other persistence techniques that this like list of recommended tools wouldn't find necessarily. And I want to be a bit humble a bit about this though, because a lot of these are like quite config dependent. So like what you're going to find if you use Cape in your investigation depends a lot on what plugins you're running. So of course, it depends a lot from case to case. But there's at least no like, dedicated plugin or this is documented somehow in a very good way. So let's start with IIS and SharePoint. We did a lot of investigations related to the latest SharePoint exploit. I don't know if many of you saw that. And one of the things that they did that was use this clever trick to maintain persistence. And what they did was that if we look at my SharePoint server here, zoom in just a bit, we see that SharePoint is, you can have it in the cloud and you can have it on-prem. This obviously affected the on-prem version. And in your server, you have this like IIS web server. So if you look under like the normal iNet pub, you have your www root, VSS, virtual directories, and then 80, which is some kind of number. I don't even know what it is. And you see that if you open like IIS, you see it's registered as the different sites and so on that you have. So here you have the SharePoint 80 thingy. If you go and browse to that, it looks something like this. So it's nothing weird. And if we look into the web config of this server, we see that it has this machine key configured. So as like in the recent versions, they are encrypting these. Back in the day, it used to be in plain text. And I'm sure that all of you that work with pentest knows about view state deserialization bugs. So basically in IIS, this is nothing new at all. But the way that they are using this is kind of new. So if you steal this view state secret, which is encrypted here, and you decrypt that, and then you use that to sign your own payloads, then you can basically execute code through a deserialization bug. And that is something that, for some reason, Microsoft has decided not to fix. So it's just kind of like an unpatched vulnerability in IIS. So if you leak your machine key, then you have a persistent remote code execution. The only thing you need to do is kind of be able to reach an ASPX file. That's it. However, this one is encrypted here, just because it's, I guess it's because you don't want to have like a local file inclusion kind of situation. However, we are admins now, right? Because this is persistence. We're admin on the SharePoint server, and we want to add persistence to this server. So what do? We steal this secret. And the way we steal it is that the only thing I did was putting this DLL file in the bin folder. and that's it. This is also only temporary for stealing the secret, because it's encrypted with like DP API and so on. So I can either do it like and steal those master keys, but the easiest way is just kind of to load something into IIS, because there you have the secrets in plain text. So what I do then is that I go into my other machine, and let's zoom, and I have this script which goes to, actually it's on the other server here. So let's go to the right server. So it's portal.hack.ad. And let's see if we had a specific path. But yeah, let's just go here and see what happens. And we do the first command, which is the hello, and see if we can reach. And it says that the module responded with hello marker. And the identity running is this one. So then we run the dump command instead. And we see that we dump out these keys in plain text. And this is pretty much all you need to do. When you have this, then you have persistent access to the server. That's pretty much it, right? Now, when I've done this, and that was just like one way of doing it, of course. You can drop an ASPX file, you can steal the machine, you can steal the DP API keys and so on to decrypt the machine key. But after this, I just drop this because I don't need it anymore. So there's nothing to find on the system. The only thing the threat actor has is that they know these machine keys. And when they want to get back in, they just trigger the deserialization exploit again, because they have a persistent remote code execution. So that is problematic on SharePoint. And Microsoft added like a machine rotation automation to resolve this. We saw this like widely spread during the some time ago, and yeah, this is one of the solutions. But of course, this is only for like the most recent versions, which of course all organizations run. So it doesn't work for everyone. The other problem is that this kind of reminds me of this demo that my colleague Fabio did back in 2020. Remember that I said that this is really old stuff? So back in 2020, there was this exploit in Exchange, which was that you could bypass authentication, read a config file, extract the machine keys, and execute code. Because, yes, Exchange is also IIS, right? So if you have an Exchange server, you can do the same thing. So if we go to my same here, and then instead we point it to my Exchange server, which I've done exactly the same thing. And then I go to like this file because it doesn't have any authentication. So you can visit that anonymously, which is kind of useful if you want to dump out the secrets again. And we have dumped all the secrets, and now we have persistence to the Exchange server as well. And then, of course, you can remove all the like bin files and everything on disk, so there's nothing to find for the forensic investigators. If we look at this in the EDR, so all of these machines that I'm demoing now have Defender running. We can see that when this runs, the only thing that happens is that the module is loaded. That's pretty much everything. And it's unknown, of course, because this is my DLL. There's no like alert or anything like that in the EDR, because I'm only stealing the machine keys that gives the persistent remote code executions forever. But it's kind of a cool technique that we've seen. And of course, there's also like these logs and so on, and some opportunities to find this. But it's kind of problematic in the sense that, you know, think about how many servers run IIS. Like your domain controller, they probably run some kind of like IIS. Hopefully not. But your like ADCS server, like your certificate services, they definitely run IIS. And they definitely have some unauthenticated IIS endpoints, because you need to be able to enroll certificates and stuff like that. So there's so many Windows servers out there running IIS that you can use this to get persistence to. I'm sure you have seen, like if you're a pen tester, you have very likely seen this page that looks like this. this page, right? You see this all over the place internally when you run your internal scans. And you can just think like every server that you have this on, you can just steal the machine key and then you have persistent access to execute code whenever you want to. It's kind of useful. So that's one way. Another way, which is quite tricky to find and see as a forensic investigator and a detection engineer, is VS-Man plugins. I'm sure you know about like PowerShell remoting. So it's like this protocol to manage Microsoft machines to run PowerShell remotely, as you hear in the name. But what you do is kind of that you run with WinRM, and then PowerShell remoting is kind of a plug-in to WinRM. It's kind of Microsoft's implementation to that open protocol. And the way that that looks is kind of that you have this VS-Man or WinRM, and then you have plugins to that. But thing is that we can kind of roll our own plugin. And this is quite useful because it's also very, very hard to see. So if you look at this machine here, I have just kind of updated this. Sorry, I'm going to zoom. So I ran set item VS-Man localhost plugin Microsoft Windows file name, and then I pointed it to my own PowerShell plugin. And how did I build my own PowerShell plugin? Well, PowerShell is open source these days, so I downloaded PowerShell, I built PowerShell, and I added my own hooks where I want to execute my custom code. And then I just override the default one, and when it runs, it's going to trigger when someone uses PowerShell remoting towards that machine, if that makes sense. So if I, for example, run here, who am I, pointing to Exchange Mail, oops, then this plugin is going to be loaded on that server. And I, as a threat actor, can't do this to trigger my own persistence, but I'm pretty sure that every now and then, some admin in the organization is going to use PowerShell remoting to the Exchange server, because that's kind of how you manage Exchange servers in a lot of organizations. So when they run invoke command, or they use like enter PS session, for example, will do the same thing, then my persistence will kick in again, meaning that it's tied to someone unknowingly just kind of using a legitimate service at the machine. So now that I've done this, let's go back to the, well, actually now we're at this one. See if we load, see if we can see what that looked like in the EDR. Yeah, now here we have the previous demo. I guess this might take some time to just load the right data. You can do it. Let's see if we update it like that. Here we go. So we see that who am I is invoked remotely using DCOM, which is almost what I did. And here we see that it's created by WinRM. This is like a very descriptive, good thing. And let's see, I mean, what we should see here is basically also my malware loading, because what I guess I haven't showed you, but you see that also here in the POC, I also writing my log here for every time it's executing. So my malware is also running and writing that POC log on the system. But the thing is that it just kind of doesn't show this at all. The only thing that it's showing, and I've tried to really tried to make it find my DLL, but for some reason Defender doesn't really forward that DLL as like even raw telemetry data. So the only thing I'm finding is the system management automation, which is, for the record, my bad system management automation DLL, but not the PowerShell plugin DLL. And we see that actually that search, I can probably do that search again. If we search for PowerShell plugin, we see that the last event on the server is this morning when I prepared my demo and ran this like set item, something like that. So the actual loading of the DLL is never recorded, which means that we kind of have a place to load a DLL on a Windows system that runs a fully patched like antivirus and EDR, and apparently it's completely silent. So this kind of thing is quite useful, and it's just kind of something that, you know, to be fair with Microsoft, like they can't load every single event to the EDR, right? They need to kind of prioritize and send the telemetry that they think is going to be the best telemetry. But this one is quite interesting because, you know, we don't even see when it writes the poc.log file. The only thing we're seeing here is when I opened and validated that the file exists. So, you know, if I do that same thing again, you see that I'm opening the file here and blah, 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 and so on. Then that is going to pop in because it's like Notepad is loading that file and so on. But the actual creation by the malware of this file is not being recorded as well, which is kind of odd. So I think that still this kind of shows a good example of where we can look at the malware from different perspective. So here we have like, when I did the set item, for example, that would be the installation phase, which I talked about before. So we have the, if you remember, we have the installation phase, we have the dwell phase, and then we have the activation phase. So obviously the installation phase, I really screwed up here because it's really obvious if someone looks at this. And this is something that gives us a good opportunity to detect the persistence, because we can detect the installation of it. However, the like activation and the dwell time is basically invisible in Defender for endpoint. I haven't really tested it in CrowdStrike or any other solution. So, and again, like I'm not like bashing on any solution in particular. My point is just kind of that if you're a red teamer or if you're a forensic investigator, you just kind of need to know that you can't just run auto runs, or you can't just, you know, look in the EDR and then be sure that you're going to see everything. If we actually we can also search this and see if we get this event. So here, like we have the we still don't have any load of that file. If we do folder path like this and do all of them, you can see, for example, my demo module being loaded. So we would kind of expect that this kind of event would show up for the other one as well, but for some reason it doesn't. So if we move on, we see my backup screenshots here is not really used because for some reason the internet actually worked, which is great. And let's move on from all of that to something else, which is the network part of the persistence. So when you do some kind of persistence, you need to have a callback in one way or another. You don't necessarily need it if you have a persistence that you can trigger yourself, but then that is kind of like a reversed callback. But in a lot of situations, you're going to have something that calls out every now and then and checks, should I go active again? And I mean, you can do this in a really, really complicated way and try to do like, you know, DNS tunneling and domain fronting, and there's all these really, really cool techniques to hide your traffic. But you know, the most effective is kind of the simplest, which is to, if the organization is using Azure, then use your C2 in Azure. If the organization is using a lot of AWS, then use AWS. You can set up your own resources in the same hosting provider that the organization is legitimately using, and it's going to be really, really hard for the organization to pinpoint what is bad and what is good, right? It's kind of the same as with the, you know, if you're using AnyDesk or these like really simple techniques, like use what the organization is using, then it's really hard for the organization to find it. So just kind of keep it simple would be my suggestion. If we're looking at this from like the Defender perspective, it's just kind of a question of trying to map, like if something is talking to, for example, AWS, like what should realistically talk there? Like if we have endpoint telemetry, we can see what process talks to a specific domain, then maybe we can try to filter this down and see that, but this still doesn't really make any sense. But as a red teamer, you can also kind of think in those terms, right? So, for example, if you're using like the classic side loading in Google Update, and then you're talking to Google Cloud, then you have a Google binary talking to Google, and it's going to be really, really hard to write some kind of detection for that. An alternative of this, which is quite common, is that you are using a legitimate service. So you're, for example, using, say, Dropbox, and using that as a staging mechanism to upload a command, and then you're reading the command from the other side. But you usually don't really have to do that even, because you can kind of just host your own C2 in a legitimate hosting provider and hide that way. So when it comes to the conclusions, I think that the easy part works, and that's kind of the key thing here. So try to don't do the like overly complex things, because usually in my perspective, this is kind of what bites the threat actor. Like, you know, we've seen many cases where, for example, the threat actor is time stomping their files, and that time stomping is what caught them. So when you're trying to do this kind of thing to hide, it can usually be counterproductive. And same thing when it comes to like clearing the logs is probably the stupidest thing you can do as a threat actor, because that really, really shows that someone was here and is trying to hide. So when you have a threat actor that has like cleared the logs, you kind of have their path already, because like I showed in the picture before, like the event log is just kind of one evidence, and just clearing one log is usually not enough to hide anything. You're just kind of showing that you were there. When it comes to the persistence in general, when it's a good persistence technique, you kind of have a good installation method, so you can install it without leaving too many traces from the actual installation. And then the dwell needs to be silent as well, and of course also the activation. But when it comes to the activation, it's usually tied to how well your C2 is running, like your specific payload, so that whatever rat you're running. Meter tactic, if you're a defender, it's a really good start. And to be honest, like we just kind of need to start somewhere. So start with Mitre because it's a quite good coverage of everything. But of course, if you're a red teamer, you should also start with Mitre and then don't do anything that is written in Mitre, because that's what everyone is following, right? So just kind of figure out what is in there, and if your detection or like if your technique is described in there, then move on to something else. Finally, I think it's important that we, as red teamers, adapt to the target, and as defenders, can't just like, if something is talking to Microsoft, it must be good, because it's just not that simple, right? So we need to kind of look at it from a network perspective and endpoint perspective, and use the legitimate tools that they have in the environment, and use the legitimate network services that they have, and make sure that you melt into whatever already exists. One thing to end with, and I think it's back to the point with that easy things work. You might have noticed that I didn't talk about like, you know, rootkits or bootkits and these kind of super cool things. And the simple reason is that like we very, very rarely see them, because yeah, like I've said 15 times now, the easy things work. So why would you bother developing these super advanced backdoors when no one is even looking for your, you know, PowerShell profile script, right? Because a lot of organizations, they don't even look for persistence to begin with. They roll back backups, and then they roll back backups with the threat actors C2 in them as they are, just untouched. And they're like, great, we're back from the ransomware now. Right? So, I mean, if we just start looking for this, I think that would be a very, very, very good win. And I think it's kind of a joint thing that all of us needs to figure out somehow to, yeah, try to look at this. Because it's not great if we in our like society have all these, you know, backdoors and sleeper cells, whatever you want to call them. So let's try together to find them. And thank you all for staying and watching this final presentation. And yeah, see you next year. Woo! Woo!
Thank you very, very much for that nice talk. Now I'm back. So, final round of question. Who wanted to ask the last question? Raise of hand. Do we have anyone?
Anyone in the crowd? Can I see a hand? Oh, we got one right here.
Nice.
Have you found any backdoors on your personal machine?
That is not yours.
No, then it's not mine anymore, right? That's a joke. I mean, I wouldn't if I had. I wouldn't tell you, right?
True. Anyone else? No?
Seems to be about it.
Cool. You can just grab Alexander afterwards. You will be around for a little bit.
Thank you again so much.
Thank you.
Now, stick around and we're just going to say some parting words.
Yep. Everyone is dead silent.
Yeah, everyone watch
you should.
Jesper try and do computer stuff.
Here it is. Hopefully it works. It's red. The battery is running low. It's actually true.
I think it's gray, man. Get your eyes fixed.
I have a thing here.
Oh, yeah, that's actually true. You should plug that in.
Yep.
Thank you so much.
Thank you. Okay.
So.
Are you tired of us yet?
Yeah.
Yeah, I'm sort of.
I'm tired of myself at this.
I have a verb for this. I call it peopled out. It's not you, it's me.
Right. Yeah, it is actually you.
Which is pretty cool. Or is it?
Well, we'll see, I guess.
Yeah, let's. We have some stuff we need to do more. Let's do this.
Hey,
this
right.
This is a new thing, so you should actually, visit our here's.
There's a winter pub.
Winter pub is happening.
We've done it once. We're going to do it again.
Yes, it was a great success, and we need it in November, right? Tiro,
Yeah.
November. Yep.
7th? Yes.
Yeah. Hey, we can guess.
Sweet memory, right?
And you'll find this on our webpage. You just go there, and if you want to sponsor this, we're more than happy to help you out with that.
Yep.
Yep. Perfect.
Actually, you can help us out, but we'll be happy to take your money for it.
Yeah.
That'd be great, actually.
And but we can't do this alone, so we want to thank our sponsors, obviously, to make this. That makes this event happen. So thank you very much.
Big hand of applause for them. Especially our premium sponsor, Mullvad, of course.
Yep, which is really, really nice to have you all with us. But me and Johan doesn't do this alone, so we want to
certainly don't
get all the people that actually work up on stage, please. Come on.
Come on, come up here. This is how many people it takes to actually run a con. We're just up here being monkeys. These guys make things happen.
Oh, just soak in the crowd. Yeah, thank you everyone for joining us this year, and we hope to see you next year. So thank you so much for making it.
It's been an amazing con. You've been a great audience. Let's do it again sometime.
Thank you.
And of course, as Alexander mentioned, the guys running the lights, sounds, everything else, the smoke and the sparks, but wouldn't be anywhere without you guys. So.
The CTF team as well.
Of course, the CTF crew. I don't know if they're still here. They're probably in a...
There's one.
Yay! Big hand of applause. And maybe most important of all the speakers.
Yep.
Come on. Yes, get up here. All right. What else, Jesper?
I'm not sure. I think we're there.
Are we done?
I think so.
Is that it? Oh my God, it's been a year already. It's gonna just feel like the blink of an eye until next year, but it cannot go by too fast. So please come and join us again for next year. Thanks again to all of you. Thank you.